management system, that is DBMS popularly known. It is a software package which facilitates creation and maintenance of computerized databases. And then database system as a whole, it is the composition of the DBMS software together with the data itself. So DBMS, as we mentioned, is a collection of, it is contain information about a particular enterprise. It is collection of interrelated data. It is a set of programs to access the data. And DBMS also contains information about a particular enterprise. It provides the users with an environment which is user friendly and convenient, and at the same time efficient as well. The functionality of DBMS is to define a database and store the database, load the database on a secondary storage medium in a computer system like our disk, the system disk. Then it provides the facilities to manipulating the database through queries, through generating reports, allowing to performing updates, insertions, etc. Then there are other features of databases as well. It provides a lot of security aspects to protect the databases from the potential threats. And also it provides tools for presentation and visualization of the data which are stored. We all are aware of database applications. This slide actually, I have listed some of the database applications, but I'll brief it up. We have database application in all concerns now, starting from banking, medicines, medical sciences, medical hospitals to university, everywhere. So we need a wide range of database efficient software packages to deal with these applications. Now coming to the next slide, where it is purpose of database systems we are keeping, why we need a database. The next slide, please. Earlier in older days, in early days, database applications were built on top of file systems, which means early days, I'm meaning the days of about 1960s or even into some days of 70s, some years of 70s. But drawbacks of using file systems were many. There were data redundancy and inconsistency. Data redundancy means the same data has been replicated again and again, and it related to data inconsistency because when insertion, deletion, or any updation performing in the files, all files are not equally updated. So that means different files contain different version of the same data, same topic as such, data on the same concept. Then multiple file formats are used. Then difficulty is in accessing the data stored in files. And every time new programs are required to be written to carry out every new work on the files. Then data is isolated in different files. There are other associated problems also. It is like integrity problems and integrity constraints, like how to check whether the data is correct or it is in correct format. All those problems were there. And also in file system, it was difficult to add new constraints and change existing ones. So the drawbacks of file system, again, the atomicity of updates, like in database system, this issue was handled very efficiently because of the atomicity properties incorporated. Atomicity means one operation, either it is performed or it is not performed. Now again, it is not feasible in file system to provide concurrent access to multiple users. Today, we can have the same database accessed by multiple users from multiple locations. For example, railway reservation, airline reservation, all these are accessed at the same time from multiple locations across the globe. So these were the things actually which were differences with the file system and which motivated the to devise database systems as a whole. Now, what I mentioned mini world a few minutes ago, mini world, I have provided an example in this slide, what mini worlds could be as part of a university environment. Suppose a university environment, you want to have a database. This is just a snapshot. We can have a mini world considering students, the courses, sections of courses, academic departments, instructors, that is the teachers and other persons involved in teaching, putting together. This could be a mini world example. However, this is just a conceptual thing. Actual university implementation or such implementation will be much wider and much more I mean, in detail. Now, quickly, I'd like to just mention about the characteristics of database approach, because we have considered what were the problems with the file systems. So, how these problems were addressed while designing a database, designing the database approach to DBMS concepts. First thing, self-describing nature of the data of a database system. A DBMS contains a catalog. Catalog is about the metadata. It is data about the data. There are details, what the data means and all those things. DBMS provides isolation between programs and the data. Unlike in case of file systems, where we have to write programs for every file, here in DBMS we have generic programs, and which keeps the programs are insulated from data, which means we can write multiple programs on the same data. That means we can process the same data in different ways, the way we need. So this concept is called program data independence. Data abstraction. Now, data abstraction is a key to the design of the modern database systems, because with the advent of advanced programming techniques, data model is built, and based on which a conceptual view of data has been created, and which lead to data abstraction. So that means abstract view of the data helped in modeling the database in a very user-friendly manner in different, for the same data in different circumstances we can present it. Moreover, the DBMS systems, database systems, support multiple views of the data. Every user may see a different view of the same database, depending upon their need. So now database approach, some of the characteristics. Moreover, in database approach, data can be shared among multi-user situations as well as in transaction processing. Now, a quick look in what kind of database users we have today. We have two broad categories of database users. One is the kind of users, those who actually use and control the content of the database, commonly called as actors on the scene, and those who enable the database to be developed and the DBMS software to be designed and implemented. These are called the workers behind the scene in general terms. Now, actors on the scene, like DBS, one common involvement is the database administrator, who is responsible for authoring the access to the database, coordinating and monitoring its use, acquiring software, installing, and also judging the efficiency of the operations. Then the database designers, they are responsible for the actual database making, actually define the content, define the structure, constraints and functions. And the end user, like us, the way we use the database we want. All these facilities are provided by the database designers and the administrators. Now, here in this slide, I have mentioned categories of end users. I feel I should not go to the details of it. This is a general reading, and everybody can look into this once the slides are being distributed all over. Just I'm mentioning that there are kind of casual users. This is in the next slide, please. The naive or parametric users, there are sophisticated users as well as standalone users. So this slide is general one. Everybody can read and understand. There's not much in it. Now, these are some of the advantages that are with the database approach. It controls redundancy. It allows sharing of data. It restricts unauthorized access to the data. Provides persistent storage for the program objects. Persistent storage means in case of normal programming or files, the data which were used in programs would be deleted once the program is closed, program is switched off. But in case of DBMS, data is stored permanently in the storage, and anytime any program can access this data. So that was persistent storage. Providing storage structure for efficient query processing. One of the most important facility with the DBMS system, database system, is that query processing, because on the same data, we may have multiple different type of queries. We may view the data, we may view the information from the data in different ways depending upon our need. So therefore, query has to be very much efficient, query processing, and DBMS provides that. Backup and recovery services. There are multiple interfaces to different classes of users, representing complex relationship among the data, and also integrity constraints and inferences and actions using different rules. There are many advantages. Here are some of them. Now, there are some potential implications of using DBMS approach or database approach. The one thing was that with file systems, there was no standards across the applications. But with DBMS, there is a universal standard has developed. The data once stored in DBMS, used in DBMS, has to be modeled in this way. There is a universal standard developed, and that standard is followed. Now, this actually reduced application development time, allowed flexibility to change the data structures, and also availability of the incorporation of up-to-date information and availability. And also it is scalable, means we can have volumes of data stored and processed in an efficient manner. Well, the next two slides actually contains overview of database development, historical development of database technology. This is again a general reading, but I'd like to just mention all starts in 1960s with a effort to reduce the problems faced with the file systems. So early database models were introduced in 1960s, followed by relational model, which we all are aware of, relational database systems, or popularly known as RDBMS, well in the beginning of the 1970s. Subsequently, in 80s, when the object-oriented programming held the key in the world, then also it is felt that database should be oriented towards object-oriented formalism or paradigm. So OODBMS, object-oriented DBMS, were introduced in the 80s also, and by early 90s. And now, when everybody is working on internet, so at this moment the database has beyond 2000. It has gone on web, and it has included web and e-commerce applications containing data in HTML and XML and other different formats. So it is developing based on the need and depending on the growth of the technology as well. Now, these are various applications. I'm skipping this extending database capabilities slide. This new functionality is added for different applications. So, okay, just hold one moment. So, extending database capabilities actually happened as we have moved from 60s to now 2020s. What happened? Technology has gone up by miles all these years. So including a lot of new computational needs have come up based on the machine learning, artificial intelligence domain. So database technologies has also incorporated these things. At the same time, data not only remained in text format, it has become audio and video format is also there, audio and video data. So all these are now getting incorporated in the database technology. Moreover, this is one thing, data is something always increasing. It is not reducing. It is all the time increasing and piling up. So the need was felt in 90s that what to do with this huge repository of the data, not only in database systems, in different, file repositories, internet bases and everything. So the concept of data mining came out. That means to find the patterns which is hidden in the large amount of data. And nowadays the tools, database application tools has also included data mining software as part of the DBMS systems. Now, one thing like when not to use a database, there is again like we tend to use database in everywhere, but there is a limitation also in the sense that few things because database installation actually has some high initial investment and possible need for additional hardware, and there is overhead for providing generality, security and concurrency control, etc. So therefore these are some main what is called the deterrents for using the databases. So there are certain situations when the database may not be necessary, like in case data is simple and well defined and it is not too large, then no need to use database systems. But when it is big, then it is necessary. So, and there are situations when database we cannot handle those kind of things using database. Like if the database system is not able to handle the complexity of the data because of modeling limitations. Because one thing again, that when we are trying to talk about database, we need to model the data. Now, data is of varying nature. Today, in the 1960s or 70s, data was just numbers or some character strings. But today, data is everything. It is sound, video, audio, visual, still, everything. So all kinds of data is not possible to be modeled in a similar way. So when there is modeling limitations, it is not recommended to use database systems. And that is why in internet, you do not have any standard database actually. It is a mixture of all kinds of unformatted or semi-structured or unstructured data. Now, here is data we are talking about, levels of abstraction. Now, coming to the next is to the internal situations. So, how do we model, how do we view a database system? Actually, in modern database systems, data is actually viewed at 3 levels. The level which is very closer to the user is called view level, and the level which is very closer to the machine hardware, that is called physical level. So these 3 levels of abstraction has been designed or proposed. The physical level is the closest one to the machine hardware, and it describes how a record is stored. For example, customer record is stored in the physical database, in the disks. Logical level, how we process the stored data, because we mentioned that stored data is stored once but processed in different way at different location. So this is a skeleton SQL code, very simple one. Here it is type customer equal record, name is a string, street is a string, and city is an integer, and then this code is integer. So what is it doing? It is storing. It is storing a logical. It is creating a logical level of abstraction for the data stored in a database, and it is showing.
Excuse me, sir.
Yeah, please.
Can you please explain how city can be an integer?
How?
City the field.
City, yeah, city actually, if we code the city name, suppose we have got multiple cities, yeah, we can give codes, like city can be coded like 1, 2, 3 like that, because we are keeping a meaning to the metadata, and that's how we can keep it an integer. However, we can use a string also, there is no harm in it.
Okay, sir, thank you.
Yeah, and then this, and similarly another like type instructor, it could be a record. Here ID can be string, name can be a string, department name can be a string, and salary can be integer. So this is actually the logical level of the data, logical constructs. We'll come back to this again later in the discussion. Then provides a view level. Application programs view level, the characteristics is that we can run many application programs on the data, but it has to hide the details of the data. So that is the view, and view also can be used in different purposes for different ways, like hiding certain information if required. Now, in order to create a 3-level architecture to model the data, we need to have some constructs. So the main construct is called the schema and instance. So schema is actually a logical structure of the database. So when we design a database, we have to first design the schema of the database. Here, one example we are keeping. The database consists of information about a set of customers and accounts and the relationship between them. Just an example. So here, this is analogous to type information of a variable in a program. So schema is the logical structure. Now schema can be at 2 levels. One is at the physical level and one is at the logical level. Physical level database design is at the physical level schema, and logical schema is designed for the logical level. And instance is actually the actual content of the data. So schema is something like a blueprint on which we are defining different data or creating different instances of that similar type. So the instance is actually the actual content of the database at a particular point of time. This is analogous to the value of a variable in a program. So in general, if we just see the analogy, schema is the type of a variable, just like integer, x if we say. So what is the value of x is 5 is assigned to x, that is an instance. Then the other thing is that physical data independence, for which is a property of the architecture. It is the ability to modify the physical schema without changing the logical schema. So logical schema, what the program based on which the data is viewed from the logical level, the physical schema can be changed. So this is the physical data independence. So in file systems, this was not possible. So application programs that are written on a database, these are actually depend on the logical schema that has been made. In general, there is an interface between various levels and components, which should be well defined, and so that it changes in some parts do not necessarily influence some other parts. So basically, the modular structure is emphasized in the design of the database. Just one. Now coming to data models. So data models, then it is a collection of tools for describing the data, the relationship, the meaning of the data, data semantics, as well as the constraints on the data. Like for a particular kind of data, even if we declare it an integer, we cannot have any integer value associated with it. For example, age of a human being. Normally we'll restrict it say up to 100 or 120. So that is actually certain kind of constraints, and more constraints are defined on depending upon the meaning of the data. Now the one model is entity relationship data model. It is for design. It is mainly for database design. And then relational model, as I talked about, object-oriented data model or object-based data model, and semi-structured data model, XML, and all these things now. Now, there are other data models like network and hierarchical model, which were older in the 1960s. However, there are some installations and operations are still on in these models. So, data model, therefore, is a set of concepts. The next slide, please. To describe the structure of a database and certain constraints that the database should obey. And data model operations include operations for specifying database retrievals and updates by referring to the concepts of the data models. Operations on the data model may include basic operations and user-defined operations. Now, based on the views that we have just discussed a few minutes ago, there are categories of data models like conceptual, that is the high level and semantic model, physical level, low level and internal model, and implementation, that is the representational model. This history of the data models, the next two slides I'll be skipping because one can read very well this. This is just a collection of the facts. I'm skipping this next two. I'm coming to view of the data. In slide number 25, please. To the view of the data on 20. Yes. This is a very general view and common view of the three-tier architecture, it is commonly called. So if you see at the bottom, it is the physical level, closer to the machine. In the middle, the logical level, and on top, multiple views are facilitated. On the same logical level of abstraction of data arrangement, different users can obtain different views of the data through the application programs. So this is the three-tier model of the data which is proposed, and this creates all the three levels are independent of each other in the sense that the one level does not affect the other level or influence the other level if any changes occurred in that. So applications programs are developed in such a way. So this is called tree schema architecture in the next slide. So it facilitated what is called the DBMS system design with program data independence with support of multiple views of the data. And it allows the DBMS schemas to define at three levels. One is internal schema, that is at the internal level to describe the physical storage structures and the access paths to the data. Next, a conceptual schema at the conceptual level to describe the structure and constraints for the whole database for the users. So it uses a conceptual data model. An external schema is at the external level to describe the user views. And this requires mapping. So there exist mappings among the schema levels to transform the requests and the data. Programs refer to an external schema, and we are mapped to the DBMS to the internal schema of execution. And how data independence has come about in this architecture. It provides the capacity to change the conceptual schema without having to change the external schemas and the application programs. That means logical data independence is provided by the ability in this architecture with the capacity to change the conceptual schema without having to change the schemas for the application programs. It provides the physical data independence, which is the capacity to change the internal schema without having to change the conceptual schema at the logical level. So when a schema at a lower level is changed, then only the mapping between this schema and the next higher level schemas need to be changed. Like if the schema at physical level is changed, then the association between the physical level and the logical level, middle level, these are to be adjusted. The higher level schema themselves will remain unchanged. So therefore, the application programs need not require to change once there is a change taking place at the physical level. Now, let us come to then what is essential in dealing with these different levels of abstraction, physical, logical, and then view and all these. There are requirement of languages for DBMS. We are all familiar with programming languages. So DBMS languages are slightly different. So now we need certain level of language to define the data at the initial level. So that is called, so therefore DBMS language are called data definition language, or commonly known as DDL. This is used by the database administrators and designers to specify the conceptual schema of a database. So that is the middle level. So what happens, like in data, it is a specification which mentioned for defining the database schema. We have an example here. Like this is an SQL structure. Create table for an instructor. Let us say class instructor or teacher. In this case, we have this is a data definition language structure or code for in SQL. Here two examples I have seen. One is instructor ID. Character is a type of 5 character length. Name is a varchar, 20 character length. Department name is a varchar, and salary numeric character, keeping 82-fold decimal, took care of the decimal part. Another example in a bank account, if account is a table, once again we are using the table word. Actually, we'll find soon that this model of the database relational is actually modeled in tabular format, which is conventional to all of us. So that format. So here again, create table means data is organized in a tabular format. So here in account number, character 10 length, and balance and integer. This now in the first example, create table instructor. Here the table will have 4 columns: one for ID, one for name, one for department name, one for salary. In the second example, the table will have 2 columns: one for account number and one for balance. Now then, once this data is created, yeah.
So, sir,
Once the
in the character and the var character data type.
What?
What is the difference between the char and the varchar data type, sir?
Actually, these are 2 different types. Varchar is actually variable character length. So these 2 different types, and normally we use character for IDs with smaller character length strings. Varchar we use for longer, requiring name and department name and even address and all this we use varchar.
Okay, sir. Is there any difference in the memory space, sir?
Space-wise, yeah, character length upper limit is not there as such, but this is the thing, varchar, the variable length character string we can use. Name can be variable length. Like here, everyone's name can be of different length. So we are keeping that varchar. Okay. Similarly, department name can be of various length in characters. Is it?
So 26.
Now we need again a DDL compiler in order to compile the code which is being created by data definition language. And then there is requirement of data dictionary, means that is the metadata contents. So the data dictionary, it contains database schema, integrity constraints, primary key information, referential integrity, that is referred constraints in SQL, and authorization instruction, and all many things. These are some of the things which are just listed. Also, it has the data storage definition language. That is the language in which the storage structure and the access methods used by the database systems are specified. And it is usually an extension of the data definition language. That is the storage definition language, which is normally not handled by the users, not even DBA once created. Next, we have data manipulation language. Mostly we require to do is, once the database is created, designed and created, then we have to use mostly the data manipulation language for performing the queries. Again, SQL, now I'll come back later on. SQL is performing twofold operations. It allows the data definition as well as it allows data manipulation way. So data manipulation language is used to specify the database retrievals and updates. It is language for accessing and manipulating data organized by appropriate data model. And DML is also known as query language mostly. So query language is actually preferred by DML commands, that is data sublanguage. That the commands are called also known as data sublanguage. It is performed on the same language and can be embedded in a general purpose programming language. Like we can have SQL code embedded in a C program, or even a COBOL program of the older days, and so on, or even an assembly language program. So in this case, the high level language program like C or C++, in which we embed an SQL code, then such a language is called host language. So at the same time, standalone DML commands can also be applied directly. Now, in general, we have got two classes of languages. One is procedural or low-level language. This is records at a time. They specify how to retrieve data and include constructs such as looping, etc. And user specifies what data is required and how to get those data. The other is high-level or non-procedural languages or declarative languages. Herein, user specifies what data is required without specifying how to get those data. So these are set-oriented and specify what data to retrieve and how to retrieve, for example, SQL. These are again also called declarative languages. So SQL, as you know, is the most widely used query language. Now this is one without any design concepts. This is just an arrangement or as a database. Like normally our database design we are talking about. Here I am giving a couple of examples. The first one concerns with a university database example. It contains one ID column, name, department name, and salary. And the second, this is the instructor table. And secondly, department name, building, and budget. This is the department, in which building this department is functioning from, and certain budget. The second table, like in blue and white, green and white, this is about a banking example. It contains a customer ID, customer name column, customer street, customer city, customer number, account number. So these are two database general, like to begin with. Now you will see in those two database examples how things are. Again, this is another example database in which we have, now this is about this banking example, previous slide. We have just added certain things with this table concerning here. This is a customer table. This banking database we have converted to 3 tables. And the first one containing these 5 columns. Second is account table containing account number and balance information. The third one is customer ID and account number information. You can see this table and this table can be interlinked through the account number, and account number by account number, again these two tables like the customer table and the account table can be interlinked. So in general, a database will have such different multiple tables. Now coming to SQL, we'll come back to SQL again, but it is an overview. Like suppose we have defined these databases. We have defined these databases in the system, in the DBMS. Now we need certain queries to perform through SQL. So it is a non-procedural language. So first example, name of the instructor with ID 22252, like 2222 again. So for this, again, we'll come back to this again in a more methodically. We're just giving an overview and flavor of this at this moment. So there are certain, the SQL provides us with certain clause, select from where clause. So select what we want. As per the query, we need to find a name. So that is the, now once again, I'll just go back here to the previous slide. Here in relational database terms, all the column heads, these are called attributes like customer ID, customer name, customer street, customer city. All these are called attributes of the database. And the customer table, customer is called relation. Similarly, in the second table, account number, balance, these are attributes. So now, when we are performing this query to find the name of the instructor with the given ID, then the name attribute we have to retrieve from the instructor table. In the this is in the previous database. Actually, the database about related to the teacher, that is this one. So the first one. So it will go back to this column 2222 with Einstein at physics. This information has to come out. So with this query. So here to the instructor table, it will go from instructor table. Then where it is to match the instructor ID with this string within quote we are writing 2222. So this is the a simple SQL code to retrieve the data with the given requirement. Now this is again find the ID and building of the instructor in the physics department. This is slightly more complex. Here what we need to find out the ID and the building of the instructors who work in the physics department. So in this case, the same database we have to access. This is this one, that is the ID and instructor database of the first table. So here we have to go to two tables, select two IDs. We have to two attributes. You have to select instructor ID and department building from instructor and department table. So then instructor, where instructor department instructor dot department name is equal to department dot department name, and then the department name is matches with the string physics. So this will give us the result of this query. Now third example, another from the banking database. Here find the name of the customer ID 19283 19283 7465. Here customer, here again we have to select the attribute customer dot customer. This dot notation actually tells we are extracting the customer attribute, customer name attribute from the customer table. That's why dot from customer, and customer dot customer ID, this one. Another ID is another queries that find the balances of all the accounts held by the customer with customer ID given here. Same here we have to select account dot balance attribute from the depositor and account combined. We'll perform this, and then where depositor dot customer ID is the given ID, and depositor dot customer number is equal to account dot account number. So like this we have to write the query codes in SQL for retrieving the data. However, these are again simplified by use of multiple commands later on. So application programs are generally written to access the database through one of the languages extensions which allow embedded SQL as well. Now coming to a little bit about interfaces. Interfaces are standalone query language interfaces. It provides programming interface for embedding DML, data manipulation languages, programming languages in different programming languages, as I mentioned already. It has got two approaches. One is pre-compiler approach, the other is procedural or subroutine call approach. And there are certain user-friendly interfaces which are normally we use because the kind of thing that we are talking about is not going to be very user-friendly for normal users. So for them, we need to have much efficient
Pankaj sir, you are not audible now.
read and understand. I would like to skip this one, that other DBMS interface. Then coming to other
Sir, can you please repeat? You are without audio for a few seconds.
Okay, sure. Actually, I was talking about DBMS interfaces. So the way the kind of coding that we have discussed a few minutes ago, it is not going to be very useful for or very comprehensive for normal users, like users who are not familiar with these things. So therefore, it is very much needed that for user-friendly devices has to be given in the database. So these devices are normally menu-based and through interfaces. So menu-based interfaces and popular which are required for, like for example, the way we browse the web. Similar browsing interfaces are also required for databases. That means query which we are discussing will be performed based on the menu given. Similarly, form-based interfaces for naive users, graphics-based interfaces are also designed, and even NLP, natural language-based interfaces, also been done nowadays, and many combinations of this, like. So,
okay, sir, one clarification.
Yeah.
SQL stands for standalone query language.
Pardon?
The full form of SQL is standalone query language.
No, structured query language SQL is.
Okay, thank you, sir.
It is structured query language. Yes.
So where do we use this standalone query language interface, and can you provide any example related to this interface?
Example in the sense that user-friendly interfaces, like we have, like database when you talk about as a backend, in that we can have a front-end menu-driven interfaces, or form-based interfaces are normally used by various languages, like even in earlier days it was used, Visual Basic is used, and nowadays PHP, XML, all are used for providing such interfaces. So in which we can.
I'm asking about standalone query language interface.
Standalone query language is actually required when we are using a database as a standalone in standalone systems. So SQL can perform as a standalone query language. There is no problem. It can perform on client server as well as standalone devices. No problem.
Right.
So these are about interfaces, uses of interfaces in this other DBMS interface. So which we can just go through. There is not much in it, one can understand. So next slide I'll skip. Coming to other tools, slide number 35. Here data dictionary or repository is required in order to store the schema descriptions and other information such as design decisions, application program interfaces, user information, etc. And two types of data dictionary are maintained normally. Active data dictionary to be accessed by the DBMS software or by the DBA, and passive dictionary to be used by users, also by DBA only. Now, nowadays, like the database design, which we'll talk about ER model little while from now, in which a lot of case tools, computer aided software engineering tools are available nowadays, like Power Builder, old one, Power Builder, new versions are there, Sybase, Borland versions are there, UML tools are there. So designing database is now is basically automized in many sense. However, there are still a problem exists because in order to put forward the semantics of the data in the design tools. But this is the design problem, because database design is a very complex task, and through the database design tools, design has become much more easier nowadays. Now, what we have talked about so far in the database system internals, in the next slide 36, we have just summarized in this diagram, and this is a very standard diagram available in all the journal text. In this, the three levels of the database architecture are separated. If you look from bottom, the cylinder type, in which we have got all the basic information of the data stored in the disk, contains this. Now the middle layer, it is the storage manager. Like the data which are stored at the physical level, these are to be managed by certain lower level programs. These lower level programs are in the second segment within the dotted lines from bottom, which is marked as storage manager. Here, different manager database management programs or programs are there to this. Like there are buffer manager required, file manager are required, authorization and integrity manager program is required, and transaction manager. These are all lower level, normally not accessed by anything outside. Then the middle level is a query processor. Like in the DML level, we use this middle level for query processing works. Here, if we now look from the top, at the extreme top, we have different levels of users. One is naive users, those who will simply access the data and retrieve the results. Another group of users are the application programmers who will program the database, write application programs. Another group of users, data analysts, who will write sophisticated programs to analyze the data. And in the DBAs. Now, all will write different programs and commands for their purpose. So these programs are to be transformed or translated to perform its designated task, and for that we have got this middle layer tool, that is the query processor component, in which we have compiler and linker programs for the queries, then data manipulation language queries, then data definition language interpreter is required, and these three sets are required for the high-end users, like who are application programmers, sophisticated users. But for the naive users, the application program can be directly handled by application program object code, then query evaluation engine, and through that it goes to the storage manager operations for retrieving the data from the physical storage and presenting it to the respective users as per their user programs. So whatever we have discussed so far, actually this diagram summarizes about the functionalities of the data that we have actually done so far. Anything, sir, in all at this moment? Actually, I'm almost halfway through to my lecture, or more than that. So I'd be happy to clear up certain queries at this stage, if any.
Participant, if you have any queries, please go.
No, sir. No, sir.
Sir,
Okay.
just a minute. Sir, good morning, sir. Just a previous slide. Just show me one, sir. I'll do the snapshot.
Okay, sure. I think slides will be shared. I'll request the.
Just for time's sake, I'll just analyze
Okay,
content.
sure. This one?
That diagram you said, no, sir, that one.
Oh, diagram one. That is on slide number 36. I think it's all right.
Yes, sir. Thank you, sir. Thank you, sir.
Yeah.
Yes, sir.
Yeah. Now, database architecture we're talking about. Now, this is actually database architecture which are physically built over systems. So I'll quickly go through some of the slides now. We are having three types of different architecture, four types actually. With the advent of technology, like earlier days, we used to have centralized and standalone systems where we are storing the databases and does our job. centralized databases. Now, then with the networking advances, like we are having LAN, local area networks, wide area networks, and all these things, then client-server database, and also the server technology has developed. So client-server databases have been designed. Like same database, we have to perform in client-server situation. Then the computational advancements to parallel and distributed computing are taking place. So nowadays, the database operations are even possible on parallel and multiprocessor systems as well as distributed, which is associated over a wider geographical area. Like we have a common database. Very simple example are like railway reservation and all these things. They are performed over distributed locations. So how these are maintained is nice to study actually. So the centralized and client server architecture, the features is that in centralized versus client server architecture, it has got a centralized database, and it combines everything into a single system, including DBMS software, hardware, application programs, and user interface and processing software, everything in centralized DBMS. Whereas in basic client server architecture consists of specialized servers with specialized functions, and clients and DBMS server. So the functions, like a database has different functionalities, so different servers are used for this. Now, in client server architecture, next slide, in which we specialize servers like file servers, printer server, web server, email server, and everything. Now, what are the features with the clients? Clients are provide appropriate interfaces and a client version of the system to access and utilize the server resources. Clients may be diskless machines or PCs, workstation, or even nowadays we are mobile phones. These are all clients. These are connected to the servers via some form of network. We can have LAN, wireless network, WAN, and anything, different networks. Because this was not possible in the earlier days, not even in 70s, but now these are the only de facto standard. Now we do not talk about standalone systems unless it is very much necessary, but normally it is the standard. We need to have client server application most of the time. Now this is just a comparison, and then client server architecture can have two-tier architecture or a three-tier architecture. This is different from the three-tier architecture of DBMS. This is the database system as a whole. How the database will be reached to the users from each storage and through the this thing. So the two-tier client-server architecture, it has got user interface programs and application programs. It's run on the client side. In two-tier architecture, interface is called ODBC, Open Database Connectivity, to provide an application program interface, commonly called API, which allow client-side programs to call the DBMS. Most DBMS vendors provide ODBC drivers. So client-side programs will call the DBMS commands to perform the task and communicate the results to those programs. Now, a client program may connect to several DBMSs. Now, multiple DBMSs can be there in different servers. It can connect. Other variations are also possible in clients, that is in sub-DBMS. In some DBMS, more functionality is transferred to clients, including data dictionary functions and optimization, recovery, and all other things. Now, in the three-tier client-server architecture, because the advent of the web applications, now the two-tier architecture had certain shortcomings. So therefore, it is common for web applications. So an intermediate layer is introduced called application server or web server in the two-tier architecture for the client server architecture in the client server, which stores the web connectivity software and other rules and business logic, that is constraints which are part of the application used to access the right amount of data from the database server. It acts like a conduit for seeking partially processed data between the database server and the client. Also provides additional security features for encryption and decryption of the data, because it is ultimately data is going to be transmitted and sent and received across the network. So security aspects become much more necessary and important. So those features are also included. Now, based on this, again, the various DBMSs are classified into different forms, like, as you already mentioned, centralized multiple times. I mean, distributed also and parallel also. So distributed systems have come to be known as a client-server based database systems because they do not support a totally described distributed environment, but rather a set of database servers supporting a set of clients. Now, in this distributed systems, there are multiple problems. Like, actually, we are going away from the concept of database to database establishments in the sense of these two things. So in distributed environments, it is not necessary that all the locations, distributed means the database will be connected to multiple locations which are geographically away apart. So all locations may not have the same DBMS. It may have different DBMS running on its machine. So therefore, there is a requirement of solving this problem of non-homogeneity or heterogeneity. But heterogeneous DBMS or heterogeneous distributed systems are not so easy actually to always resolve the problems. Different problems crop up. So it is therefore generally preferred that it should be homogeneous. All systems should possess the same similar nature of the DBMS. However, it cannot be excluded that certain heterogeneity will always be there in case of distributed systems. Now we'll come back again with this, that to the database design concepts, like how to design our logical, basically our task is to design the logical schema for a database. Now when you see this table which you gave earlier, it contains 6 attributes, 6 columns, and you can see the ID and the name are fine, salary is fine, but the department name is repeating on certain columns, building name is repeating on certain columns. And similarly, when it comes to physics, 70,000 is going to repeat wherever physics is appearing, and like that. So naturally the question arises, if we put all our attributes of a database in a single table, is it going to lead us to a good design? The answer is no, because it is going to create the redundancy, because same data in different types will be stored multiple times and it will lead to different issues. So therefore, what are the design approaches for databases? So normalization theory is there, which requires later. Of course, I will not be touching normalization theory today because there will be time constraints and we won't be able to do it. But fundamentally, the database design starts with entity relationship. Next slide, please. In the next slide, it is there. In slide number 43. In entity relationship model, what is entity and what is relationship? So this entity relationship model is a fundamental model for designing relational database systems or any database systems. So entities are actually a thing or object in the enterprise that is distinguishable from other objects. And entities are characterized or described by its properties, that is the attributes. Entities has got a set of attributes. And relationships is what? An association among several entities. Now, when you go back to our mini world of university, let us say, in which you have got different components are there, like human resource, let us say, students, teachers, then laboratories, instructors. So if we consider student as an entity, then teacher is an entity, then there is an association between these entities. So these associations are used to model the database, so that the problems that we have just mentioned can be taken care of. Okay. Now, in this entity relationship model, let us have this example. Just this slide. The next slide, please. In this, we are showing just indicating what are attributes. This whole table. Now, an entity will represent a table in the database system, and the columns will be attributes. The same example, I'm just indicating this here. Now, this is a simple relational database. If you look into the banking example, now you can see earlier this banking example database we have this divided into 3 tables. I'm revisiting this one. So here the customer ID, customer name, customer street, and customer city, these are put in one table. Customer ID and account number is put in one table, and account number and balance is put in another table. Simply because if we put all in this table, then a particular customer may exercise the banking operations allowed to him multiple times. Suppose same customer visits the bank every time, every day, more than once or multiple times, and if we include all this data in one table, suppose in the first table, in customer table, then what will happen, for the same customer ID, multiple rows will be introduced in this. So in all those rows, certain data will be repeated again and again. For example, the customer name will repeat, the customer street will repeat, customer city will repeat, that is address information will be repeating repeatedly, which is a redundancy. Now, one thing again, as we said in the previous slide, every column is called attribute, column name is called attribute. Similarly, every rows is called a tuple in case of relational database systems. So that is why we require to identify the data in such a way with the entity relationship model that how to differentiate the entities into different tables, convert them into different tables, so that there is the redundancy which we are talking about can be kept to minimum. But however, certain redundancy will always be required. If you look into this customer ID column, these two tables, the table A and table B, it has got the customer ID column together. That means these tables are to be linked. Otherwise, if there is no linkages, they will not be able to associate the data. So, sir, this is called controlled redundancy. Redundancy cannot be removed in databases 100%, but we have to control it to the extent possible so that the database can be functioned efficiently. However, a price has to be paid for this also. Now, as I mentioned again, this is just this slide, the next slide, in that the relational model concepts has been, I have just mentioned. The rows are called tuples, the columns are called, the attributes are the columns here. This is a sample relational database. We'll remember this for this university instructor, department instructor table. Now, entity relationship model. In this model, it models an enterprise as a collection of entities and the relationship among them. We have mentioned already. So here this diagram actually represents an entity relationship diagram. I have, for brevity, I have not used the notation. Another slide, the notation I have used. Here instructor attributes we have listed in the instructor entity, and the departmental name, department attributes we have mentioned in this column. And where we say that the relationship is that an instructor is a member of a department. So member is the relationship name. So ER model of real world, it entities, for example, customers, account, bank branch, etc. we can connect. Relationship among these, for example, an account A101 is held by customer Johnson. Now, relationship set depositor associates customer with its account. So every relationship will have a set of instances. We'll have a set of instances, and they will be connect with the accounts. And this concept is widely used for database design. So database design in entity relationship model usually converted to design in the relational model. So whatever we design through entity relationship model in a database, this is the first blueprint of a database design, is converted to relational database, including the table, which we finally implement through DDL, SQL DDL, that is structured query language in the data definition which is used as a data definition language also, by using create table constructs. So this is a traditional diagram of entity relationship model concerning bank customer and account relation. A customer has a depositor relation with an account. Account is an entity in this slide. Next slide, please. Yeah, thank you. In this, customer is an entity, as well as account is an entity. So these are the ovals in which we are listing the various things. These are the attributes of the customer entity. So these two are the attributes of the account entity, account number and balance. And the relationship between customer and account entity is the relationship called, we are calling it as a depository relationship. That means customer deposits in account money. So that is the relationship, and that is how in entity relationship model. Similarly, different entities will have different relationship, and this is a traditional notation. A rhombus or a diamond shape is used for writing the relationships, and the rectangular shape is used. Rectangles are used for writing the entities. Ovals are used for indicating the attributes, and the lines, line segments are used for connecting them one with the other. So now coming to relational model. Now a relational model actually provides the structure of the relational database. Now relational model actually proposed in 1970s, and since then it has been considered as for wide-ranging applications in the database domain, and also it has been enhanced through object orientation as well as object relational. A combination of object orientation and relational model is also proposed later on. Now the relational model fundamentals are, it is based on a concept called relational algebra, and relational algebra and tuple relational calculus, then domain relational calculus, then extended relational algebra operations, which allows modification of the database and views. However, we will not be able to do all this. We'll be doing the basic of the relational model in this presentation today. So this is example of a relation. As you mentioned before, it is contain three attributes: account number, branch name, and balance. So the basic structure of a relation is actually follows from the mathematical formalism of relation. Here, formally consider some sets D1, D2, Dn, and a relation R. So if we have a set of given sets D1, D2, Dn, and there's a relationship exists between these sets, then the relation R is a subset of D1 cross D2 cross Dn. So this cross is an operator. This is actually called the Cartesian product operator. So it combines every instance of D1, D2 up to Dn with every instance of the relation R, and creates a whole set in which every relation is a subset of this R. So it's just this will say, so therefore a relation is an antuple A1, A2, An, where Ai, that means A1 is a member of D1, A2 is a member of D2, and so on. That means if we combine D1 cross D2 cross up to Dn for a particular relation, then we'll be having every member of, say, D1 is combined with every other member of D2 to Dn, and thereby we'll be getting a ordered tuples, what is called. If we have two relations, say D1, D2, then we'll be getting ordered couples, A1, A2, A1, A3, like that. So for example, if we write it like this, if customer name in our previous relations is in the previous slide, we have in our table here we have got, customer side is given in a previous slide, so we can refer to that, but I remember at this stage. So customer names are Jones, Smith, Curry, and Lindsay. These are 4 customers, and their locations are customer street, are Main, North, and Park, and customer cities Harrison, Rye, and Pittsfield. These 3 things. That means consider customer name as D1, customer street as D2, and customer street as D3. Then if we want to construct a relation out of this by this Cartesian product, then this is just one instance is giving. This is not the complete set. In R, what we are saying, Jones, Meet, Jones, North, and Rye, just one instance. So we have picked up Jones from here, and with Jones we'll be having one attribute, one instance of customer street, say Main, taken, and then Jones lives in Harrison, so Jones, Main, and Harrison gives one triple. It is because 3 member comes from 3 different sets. Similarly, Smith, North, Rye, Curry, Park, and Pittsfield, like that. However, there will be more combinations, which we are not listing here. And similarly, Lindsay, Park, and Pittsfield. So these 4 combinations we have listed just for an example. So this R is now in relation over the customer name cross customer street cross customer city. So this is a basic operation of relational algebra to bring a relation among the instances or the tree. So now we'll come back to this. Each attribute of a relation has a name. In the next slide. So the set of allowed values for each attribute is called the domain of the attributes. Now attribute values are normally required to be atomic. That means indivisible. Like whatever we write as attribute as a column name, we should not break it into further subforms, because then there will be problems. So for example, multi-valued attribute values are non-atomic. Like some attribute we have multiple values, so they are not atomic values. However, we can allow sometimes composite attributes, but they are not atomic attributes. Now relation schema, just like we have ER schema. So ER schema, from that we can have relation schemas. So in relation schema, let us say A1, A2, AN are attributes, then R, the relation, we'll have a A1, A2 up to MA. Within the parenthesis, this is a notation for relational schema. For example, if we have a customer schema with the customer name, customer street, and customer city. Now remember customer table. So from the customer table, we are writing customer schema. It has 3 attributes: customer name, customer street, and customer city. So this is a compact notation to write the schema of a particular relation. Then algebraically, small r within parentheses capital R is a relation on the relation schema R. So this R, that means customer R, capital R here is a customer schema. So customer schema has got these attributes A1, A2, A3, N. In this case, customer name, customer street, and customer city, 3 attributes. Then RR, capital R is customer with these attributes customer name, customer street, and customer city. Then small r of capital R is a relation schema on the relation on the relation schema R. So therefore, that now we are writing, you just see in the last line, we are writing the small r, that relation name, in small, whereas relation schema we are making the C as a notation customer. Now customer schema as with a dash in the middle to distinguish between the two. So a relation instance, okay, this is in the okay, I'm coming to this. Yeah, relations are unordered. Order of tuple. Now when we represent that customer, this is another account relation with account number, branch name, and branch balance. So you see the order of tuples in a relation is irrelevant, because in a set order of the items are irrelevant, order of the members are irrelevant, so we can have the tuples ordered in any way. Now this is a relational schema example. Now database. Now therefore from there, a database consists of now multiple relations. So when we go about database based on relational schema coming through here, like this thing, then a database actually is a combination of multiple relations. That means multiple tables. Every relation will be representing a table. Now information about an enterprise. Information about an enterprise is broken up to different parts, where each relation is storing one part of the relation. Now, for example, account. It stores information about the accounts only. Depositor can be, it is a relation R. These are all small r's. Depositor stores information about which customer owns which account, and customer, it stores information about the customers. That is their basic information like address, phone number, and so on. Now, a database stores, in the next slide, a database stores all information as a single relation, such as, like say bank is a relation, then account number, balance, customer name, and so on, results in repetition of information, that is two customers on an account and the need for null values. Now what happens, if we store all information of a database in a single relation, this was the problem which we were mentioning initially. If we have a single table for a whole database, then we have this kind of problems. Storing all information in a single relation, such as say bank, like with having attributes account number, balance, customer name, and all others, it will result in repetition of information. That is, two customer own an account. Then if the need for null values, like in certain cases for certain attributes there will be no values will be generated, so that time we have to store a null value in those relations, which will be again have to be dealt separately. Now what is the remedy from this situation? Like, this situation can occur. It is not that arbitrarily if we cut down the size of the table and this relation, this problem will be taken care of. No, it is not like that. We have to see which attribute is related to what, which one, and how to reduce this problem. So for this, there is a theory called normalization theory, which deals with how to design relational databases. Now, we will not talk about this today. Now, this is an example for ER diagram of the banking, so that I mentioned as I do it before, so that can be understood based on what we have done already. Now, another concept is in relational database design is keys. Keys actually required to identify a particular relation uniquely. So an attribute of a particular database table will be database relation will be designated as key so that we can identify every tuple of the database uniquely. I think I'm coming closer to my time, 11 o'clock, only 5 minutes are left. So I'm quickly going to do, and then certain things are still there which I could not complete. So K is in this case, in case of keys denoted by K. So K is a subset of the relation schema R, first of all. So K is, first of all, is called a super key of R the relation schema actually. If values for K are sufficient to identify unique tuple of its possible relation RR, and here by possible R we mean that a relation R that could exist in the enterprise we are modeling. So the whole idea is to identify every tuple. That means the key attribute, key is an attribute, that means one column of the table will be called key, and we'll be calling that column of a table as key, which will always have unique values. That means it will not store duplicate values. So and K, that key attribute is called a candidate key if K is minimal. That means sometimes what happens in different tables, I'm just saying that a single attribute may not possess this property. So therefore, we have to try combination of attributes. So just like sometimes customer name can be a key, but customer name can be a repetition. Say two persons may have same name. In that case, customer ID and customer name, customer ID will be a better option. Now, keys can be determined for the ER entity relationship sets. So I'm skipping this one, slide number 58. I'm coming to slide number 59. So this is a schema diagram for the banking enterprise. So here we have specified the key with shaded one. In the branch relation, branch name is a key, branch city and other are the attributes. In the account relation, branch number, account number is the key. In the depositor relation, customer name and account number will be the key, and customer account name will be the key, hoping that customer name will be unique in this case. And then loan number will be key, and borrower. So in this, you see the connected lines actually. So the connected lines say different things, because branch, to the branch relation, every other relation has every other entities has got a relation. So in this case, loan and account, they are directly related to the branch. So this, and then depositor is related to account, and customer is related to depositor, or borrower is related to customer is related to borrower and borrower is related to loan. So this way we can fragment it into the whole thing, and a complete bank database for a simple application will result in 6 tables, as 6 small tables. Small in the sense that it is small in terms of number of attributes. The result table will be vertically growing. Now some overview. I think I've got a couple of minutes time to look into the query language concepts. Relational algebra, query language, actually SQL was a query language. Then relational algebra is also a query language. Relational algebra is a procedural.
Sir, you are not audible.
Pankaj sir. Pankaj sir, you are not audible. Sir, your voice is not audible. Yes.
Hello, sir. Your voice is not clear.
Yes, yes. Please be patient. So sorry, is having some connection issue. Pankaj sir.
Now?
Yes, yes, sir.
Sir is getting back.
Yeah, it is actually hung up. That's why. Yeah,
Okay.
I rejoined. So
Yeah, please go ahead, sir.
it's 11 o'clock now. Actually, time is already completed. So should I summarize?
Yes, sir.
Time for the next session has come up, so I should summarize, I think.
Yes,
Okay,
sir.
sir.
Yeah, thank you. So actually, I had planned to cover the relational algebraic operations with examples and definitions, as well as the SQL queries, for how to convert the relational algebraic operations to SQL queries in the sample database. The slide contains all the details in I have compiled. So I think the participants will be able to access it through the organizers and will be able to understand, I hope. And therefore, I'd like to just come to an end to summarize today's session with a basic historical developments of the database, just quickly mentioning in the end. So actually, database systems, we have just got a glimpse of what it is. It started in a very basic with concepts, problems faced with file systems, gradually developed, technology to develop hardware, software, programming, and storage. accessibility and networking. So as a result of which, is database is also growing parallelly. And today, from the days of standalone systems, now we are into distributed systems and distributed and parallel with the facilities provided across waves to the handheld systems like our mobile devices. So this is a tremendous development, and this development is going to grow. But at the same time, there are many challenges today, because data, as we have seen in our relational design, it is only text data. However, today's data is not about text. It is about voice. It is about audio. It is video. It is streams. So the complexities are galore. So the more research, more focused attention to develop more efficient database tools are required, and it is underway. Hope so in the future we'll be seeing different advanced technologies to deal with this, particularly in the domain in the internet, which is a repository of completely unstructured and semi-structured data. So with these words, I hope participants, I have been able to reach the participant to a certain extent. And thank you one and all. Thank you, Dr. Murugan. Thank you, Dr. Suganya, and thank you, Dr. Shankar, for allowing me or inviting me for this session. Thank you very much.
Thank you very much, sir, for your wonderful speech. Hello.
Yeah, please.
Yes, sir. So if the participants, if you have any queries regarding this, you can leave in the chat box. Otherwise, you can directly send the mail to the sir, and he will answer your queries over the mail. Okay.
Thank you, ma'am. Thank you, sir. But sir, I have a request that at the end of the session we should have some time, question time, so that we can ask some questions directly in case if we have.
Okay.
Yeah, sure.
Yes.
If part of the problem, sure.
Okay. So,
hello.
Murugan sir, shall we proceed to the next section?
Yes, ma'am, you just acknowledge and thanks to sir.
Thanks a lot for accepting our invitation and to handle this session in a smooth way. Thank you very much, sir. Pankaj sir, thank you very much.
Thank you. Actually, time is also overlapping, so thank you very much. And participants can mail me directly. I'll be happy to respond the queries and happy to learn in the process at the same time.
Okay. Thank you, sir. Thanks a lot.
Thank you.
Yeah, ma'am. Just 1 minute. I'm sending the invitation to the other speaker. Just a minute.
Meanwhile, I think so we can give 5 minutes break to the participants.
Yeah, yes, ma'am. Yeah.
Participants, you can have 5 minutes break, and you, please join shortly. Okay, after 5 minutes.
Yeah. So our other session speaker also joined. So.
Sir, I have already joined.
Yeah, ma'am. Yeah, sir. Thank you. Welcome. So please stay online, sir, for a couple of minutes. So I think participants will take some break, then they will join. Thanks for your patience.
Sir?
Yes, ma'am.
Sir, yesterday the test has been conducted, sir. I could not able to attend the test. It was
No, madam, there is no test yesterday. Actually, we are planning to conduct only one test at the last day of the week.
Okay, sir. Okay, sir. Thank you, sir.
Thank you.
Excuse me, sir.
Yes, please.
Sir, I didn't get a link for day 3. Can you please mail me the link of day 3? I have to again go to the Cisco WebEx meeting again and again from the browser. So it's take a lot of time to join the meeting. Can you please send me a link via mail?
Okay. Day 3. So you are joining day 3, right? Yeah, Madam Isha.
Yes,
Yes,
she has
sir.
joined in the day 3 only, but she
You are joining day 3
time.
only, na?
Good morning, sir. This is Sapanjan. I've been requesting for PPT, right, sir, of day 1, day 2 up till now, sir. Is it possible to share them before the test?
Yeah,
so
sure,
that I
sure.
can...
I'm compiling the PPT like up to the last session. Maybe I will share the PPT in couple of minutes.
Thank you, sir. Today, sir. Possibly today, sir?
Yes, yes, yes. Next 15 to 20 minutes, I will share.
Thank you, sir. So kind of you.
Yeah.
Same is the request from my side, Shankar sir.
Yeah, please.
PPT and recorded version.
Yeah, PPT I'm compiling. So up to the last session, I will share another 20 minutes.
And the link for the recorded session as well.
Link for?
Recorded session.
Yeah, sure, sure. That link I will be shared. No issue.
Thank you very much, sir.
Yeah.
Excuse me, Shankar sir.
Yeah, please.
It will be shared with all the participants, I hope. The PPTs and
Actually, you are not audible.
Hello. Now am I audible, sir?
Yeah.
So I'm saying that the link and the PPTs will be shared with all the participants?
Yes, all the participants' email ID I will share.
Okay, thank you.
Murugan sir, I think so. 5 minutes is over.
Yes,
I'll
ma'am.
start
Please
the
go ahead.
session.
Yeah, please go ahead.
Okay.
It's Srinivasan, sir.
Yes, sir, I am in.
Good morning. Okay. Good morning, all the participants. So our next speaker we have with us today is Dr. P. Srinivasan from Assistant Professor Grade 1, Department of Physics from NIT Silchar. Let me give a brief introduction about him. Dr. P. Srinivasan has done his research in nonlinear optics at Anna University, Chennai, Tamil Nadu in 2008. His research at the University of Kerala as postdoctoral fellow was on semiconductor thin films. He furthered his research in nanofibers and bulk crystal growth along with his career as assistant professor at Anna University, Chennai, again from 2008 to 2018. As a part of the funded project from various funding agencies such as DST, DRO, and CSIR, he has grown more crystals with special and notable properties. His important research contribution includes spinning of nanofibers in collaboration with Dr. Etelvina, Portugal. His current interests are in image processing along with crystal growth. Besides, Dr. Srinivasan has published more than 80 publications in refereed journals and international conferences as a part of his research. Also, he authored 6 books that include Physics for Information Science and Crystal Growth. Notably, 7 students has completed their PhD under his able guidance. Currently, he is working with us, and today he is going to deliver the session on the topic computational thinking and programming. So I request Dr. P. Srinivasan to take over the session and deliver his speech. Please, sir.
So, thank you very much for a nice introduction, madam. And I am also one of the coordinator of this FDP. In that sense, I welcome you all for this FDP. Of course, I am a latecomer. FDP. Dr. Murugan, Dr. Suganya, and Dr. Shaikar are doing a fabulous thing and mentoring the FDP. So I didn't have any opportunity to meet you people and all. So thank you, sir. I am starting the session. You tell if my screen is being shared or not.
No, sir, it is not shared.
Just a second.
Yes, sir.
It is visible.
Yes, you can proceed. The screen is visible. Hello. Your screen is visible, but you are not audible.
Am I audible now?
Yes.
You are audible now.
Just a second. I have problem with sharing the screen, I think.
No, I think so.
Now I think I am audible.
Yes. Your screen is visible.
Shankar, Murugan sir,
Yes, sir.
could anybody share share the PPT so that could you share the PPT?
Yes, sir. Please share the PPT. I will project from this.
Yeah, Suganya madam, you please Uh,
Madam, do you have PPT? Short PPT?
Yes, sir. I am sending it now.
or
You can
otherwise
also you can directly
share
project
now.
from your side. No issue, no.
Yes, I am sending it right now.
No, you can share now. You can share the screen now.
Sir, I am just forwarding it to you, sir. Murugan, sir. Both the video as well as the presentation I have shared with you in the mail. You just share the screen. And video will be there. You just download the video also.
The video, second video, no, the first one.
No, ma'am, I'm not yet received.
Sir, I have shared. I have sent it to you. You have not get it.
Yeah, I got it.
Sir, you just refresh and see. I have it from my inbox, outbox. It has been sent
Yeah, I received this.
to. Which ID this one?
I received, ma'am. I received this.
Ah, you received, no? Okay. You just share the PPT, sir. Ah, yes.
Ah, yes.
Teresa, you can proceed.
Yeah, thank you. Yeah, thank you very much, madam. Thank you very much, sir. So, that was a wonderful introduction about me, Dr. Suganya. She has to do because she is my wife, no? So she has to do whether she is believing or not. She has to tell like that only. So, thank you, Suganya, for this introduction. Today, I am going to handle my session with the topic computational thinking and programming. Let me introduce myself to you. I am simple. Of course, this could be an unanimous introduction for all married male candidates. I am Dr. P. Srinivasan, produced by my mother and directed by my wife. Okay. So for if you want any movie to be a super hit, the producer and the director has to go hand in hand. If they go hand in hand, then that movie will be a super hit. Likewise, for a male person to be a successful person, these both producer and director has to go hand in hand. And luckily, I am positively and fortunately, this producer and director has gone hand in hand with me. So somehow I am able to make both ends meet. So, with that introduction,
Sir, we want to see the video of that movie also that is produced. Dr. Srinivasan also.
So this is me.
Thank you very much, sir. It is really nice.
So, thank you for the compliment. So, next slide, please. Next slide, please. So this was me when I was like that. Okay. So the same old eyes and the same old pranks in store with lots and lots of excitement. Because I have cut that quote. What is that quote means? Physics means absenta. Physics means absenta. So I was very happy, and my happiness knew no bounds when my physics miss was absent those days. of course, yeah, in the school sector, the pathetic teachers are physics teachers and mathematics teachers only. They are treated as weird creatures in the school because most of the students won't understand maths and physics as they are used to, because most of the see, for example, most of the students will dislike maths and physics. The same thing happened to me, and I was at that kind of excitement as this image shows when my physics miss was absent. I don't blame my physics miss for this, but I was not able to understand what my teacher was telling, and I was not able to follow what my teacher was telling. So naturally and obviously, if you are not able to understand anyone, you will have any anger over that person, and that will reflect on the subject also. So this is what I thought, and I didn't like physics. I hated physics like anything. So this happened up to some 6th, 7th standard or 8th standard, and I think if I am correct, it is in the 8th standard. A guardian angel in the name of my physics teacher, Lakshmi Vaidyanathan, came, and she taught physics in such a way that, such a lovely teacher she was. She taught physics in such a way that I got fascinated. And the same kind of emoticon, the boy with same glaring eyes, lots of pranks in store, and lot of fantasy and excitement. This time, the same excitement and fantasy came from me for attending the class. So the same emoticon, earlier it was for the absence of teacher. Now the same emoticon for the presence of teacher. So the presence of a teacher can a student's life like anything. I am the great example of that. After 9th standard, I started loving physics. If you want to teach anything, you have to first love that thing. Loving physics, and now I am standing before you as a physics professor. So it's all in the hands of a teacher. A teacher means not only the society, but not only the student, but the society as a whole. It is in the hands of a teacher to make a subject fantastic, boring, and terrific. So we all have a student's life in our hands. So keeping that in mind, so I just wanted to share with you, as you people are CBSE teachers, no? So I just wanted to share what I feel and what I felt as a student, and what I feel now as a professor. So next slide, sir. So I don't know, many of you might have come across this name, Walter Levin. He's a physics astrophysicist, basically a Dutch astrophysicist. He's a physics professor. He was a physics professor at the Massachusetts Institute of Technology, America, and he taught physics for around 40 or 50 years. His lectures are awesome, you know. His lectures will be that much fantastic lectures. He's known for his lectures, and more interestingly, for all those. Hello.
Yeah, sir, you are audible.
That I think
Sir,
that.
No, presentation will be coming soon, so you please proceed. You don't stop in the.
Okay. So I was where I was speaking. I was telling about this.
Walter Levin.
Walter Levin. Yes.
Physics professor.
Professor Walter Levin. And the best thing of him is that he used to give an experimental proof or a practical proof for all his lectures. Even in the class itself, he will give all kind of this practical proof for his physics annotations. That is the best part of him. So I am I would like to share one such video lecture. It runs for around 4 minutes to 5 minutes. He tried to explain the law of conservation of momentum and law of conservation of energy in demolishing of buildings. For that, he took a simple a bob in a simple harmonic motion bob, and he explained it. I don't want to go very deep into it. You just have a watch of this video, and after that, we'll come.
Murugan sir, video please.
No, let me do that video. Let me do that video now.
Sir, remove your headset, please. It is not audible.
Sir, audio is missing from the video.
Hello.
Yes.
Audio is no audio. It is there is no audio in the video. You just remove the headset, then only it will be audible.
I have removed the audio. About the headset.
Sir, I think you have to include the system audio before you start with the video. So once you
No,
started
better
checking
Murugan
it,
sir
you
will
have
play
to
the
include
video,
the system
please.
So in the sharing option, you will include audio. In the sharing option, you will get the option
In sharing
include audio.
option, you have an option called include system audio.
Oh, is it?
Stop sharing and share it again, sir.
Or otherwise, could anybody else share that video?
Murugan sir. Murugan sir, are you there?
Yes, yes, yeah. I can play the audio, no issue. Yeah.
Yes, sir. You please play the video, please.
Sir, you stop sharing, screen sharing. Just give me a minute, please.
Murugan sir, any problem?
Yes, yes, no. Wait, just a minute.
Sir, if not, no problem. We can continue with the slide itself.
No, sir, I'm just playing. Actually, there is no audio in the video, sir.
No. I have sent another Suganya.
I am sending.
No, because that video, whatever madam sent, that is, there is no audio, only video.
Okay, let it be, sir. We can continue with the
Murugan
slide.
sir, I have sent now.
Yeah.
The another
Okay.
video I have sent now, just now.
Okay. Sir, is this video is available in YouTube? Yeah, I think I got it from you.
Urlan sir, whether it is okay?
Yeah, fine.
Okay.
It will be around 20 MB.
Yeah, I got it, sir. Can you able to see my screen?
Yes.
Yes, sir. Yes.
Yes, sir. Yes, sir.
Yes.
Yes,
Is it audible?
your screen is audible. Visible, sorry.
Screen is visible, sir.
Urlan sir, if you have the headset in the system, you please remove it.
Sir, no issues. We can share that video to the participants. You come to the slides, sir.
Okay.
Srini sir, I think so. You can explain by your own this video.
Yeah. No. I think it is not streaming properly, so we can skip this video. And we can send the video to the participants.
Yes.
There is nothing to explain here, so I think we can straight away go to the slide.
Okay. Urlan sir, you share the slide, please.
So, sorry participants, so I could not run that video due to it has some streaming problem. So straight away we can go to the lectures. Okay, so today we'll try to answer all the questions. So this is our today's plan. What is computational thinking? Why is it important to think about? How might it be different from what we do now? And how can it enhance learning for students if you utilize this in the classroom? And what can happen if you're in your classroom to implement computational thinking strategies? And last, so next slide, please. So next slide, please. So, and the last opportunities to share the throughout. What are the opportunities that could be shared throughout? So, the previous slide. Yes. So what it, no. Yes. So how can you define computational thinking? No, sir, next slide. Yes. So we say computer science is more about ideas than technology. So only for all engineering subjects, it is engineering. But for computer science and engineering, they have included science, that is computer science. In all engineering, it will be engineering only. But for computer science and engineering only, you will be having science in it. So we say computer science is more about ideas than technology. What we actually talk about is what to say is human thinking skills, the practices, the perspectives, the concepts we humans use to structure a problems in a way computers can
Hello,
solve it.
excuse me,
So
sir.
that is called.
Hello.
Yes. So this computational thinking is more a thought process involved in formulating a problem and expressing its solution in such a way that a computer or a human or a machine can effectively carry out. So this is what is called as computational thinking. With the definition given, before knowing the real gist or a juice of computational thinking, we'll try to analyze it with an example of a small problem. The next slide, please. Sir, next slide, please. Yes. So all big problems or tiny problems struck or joined together. You may be thinking one thing as a very big problem. So all tiny problems will collectively combine to form a very big problem. So if a question is asked to you like this, I'm asking you to add all numbers from 1 to 200. Like one, so if you write series 1, 2, 3, 4, like 5 like that, so 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to 200. So if I'm asking you to do this addition of 1, 2, 3 and consecutively up to 200, what you can do? The next slide. Next slide, please. So one approach. What is your one approach? One approach is to do all that in head, inside your head. 1 plus 2 plus 3 plus 4, like that, so on. You can do like that. This is one approach. Sit taught. So this is a very big problem. This is a big. Now I am including some complexity into it. What kind of complexity is? You have to do it within 2 minutes. You have to do it within 2 minutes. So most of us could not do it or finish it within 2 minutes. If we do with the same approach, that is 1 plus 2 plus 3 plus 4 and so on. It is purely based on our mathematical aptitude, but still, if a time factor is given, like you have to finish it within 1 or 2 minutes, then it is not a task. It is not an easy task, and it will become a complex problem. So what we can do is, we can take that big problem and break them into different steps. Find a pattern, put it all together in a code, and then we can come out with a result. Sir, next slide, please. So this is one thing. So what I was telling, take that big problem and break into different steps. One such is that, see, you have to write 1, 2, 3, 4, 5, 6 up to 200. You can write this, and what you can do is a very simple step is to first add first and last number. Say for first number is 1 and the last number is 200. So 1 plus 200, and next one is the second number and the last second number from the last. So 2 plus 199, likewise 3 plus 198, 4 plus 197, and 5 plus 196. And if you add so on like this, what you'll be getting? You'll be getting 201, 201, 201. Like this, you will be getting 201 100 times. Is it not? So simple. Now this big problem has been broken into different small steps. So you'll be getting 201. How many times? 100 times. Sir, next slide, please. So 100 into 201. So you'll be getting 20,100. So previous slide. Sir, previous slide. Yes. So 100 into 201, that is 20,100. 20,100. No, sir. Next slide, please. Yes. So that is the answer. So what we have done in this problem, we had a very complex problem, and we tried to address it with a small step or a different step. We are just disintegrating, or we are just breaking it into small thing, and we have found a small code, and using that code we are able to find this solution for this. So this is what is called as computational thinking. So now you could understand how you could approach a problem in a different manner. So only one thing is you have to have some logical sense in it, in approaching a problem, in disintegrating a problem, and finding a similarity in the problem. So this is what is called as computational thinking. So the next slide, please. So I think it is not visible to you, but this is a Java code which gives this is a program code for finding out guess the number. So you have to guess the number. This is a number guess game. This is the what to say it, a program for guessing a number. The next slide, sir. So this is the output of that program. So from range means from 1 to say 100 means you have to guess the number. Enter the range of numbers you want the random numbers to be between. So if you are from 1 to 100 means simply 1 to 100, and you guess simply you can put some 20 or 30. Enter your guess. See if your guess is too high or too low. You will be getting, if your guess is too high, you will be prompted. Too high, it will be prompted, and if it is too low also, it will be prompted. So from that, based on that, you have to change your guess, and this computer will tell you how many guesses you had. So this is a very simple code which implements this computational thinking. And based on this only, this program has been written. Okay. So next slide, please. Okay, so this computational thinking is a problem-solving process that includes the following. So what are the characteristics of computational thinking? What are the methods involved in computational thinking? The first and foremost method, or the first and foremost step is decomposition. What is decomposition? Decomposition is nothing but breaking problems into small problems. That is, breaking a big problem, a complex problem, into a number of small problems into parts. That is the first and foremost thing in computational thinking. So the next thing is pattern recognition. Pattern recognition is nothing but identifying patterns and trends. So you have decomposed a very big problem, and you have disintegrated into many parts, and you will be able to trying to answer each and every part. Okay. After that, after decomposition, you have to identify any similarities between the problems. If there any similarity lies within the problem, or if we have two or three problems, we have any similarities between this problem. That similarity is called as patterns, and if you are able to recognize it, that is called as pattern recognition. So identifying patterns or trends or similarities. So this is the second part. The third point is abstraction. So once you have decomposed, and after that you have recognized the patterns. After recognizing the patterns, you have to generalize the patterns. So that generalization of patterns is called as abstraction. So this is the third process involved. So and the final process, or the final step which is involved, is algorithms. That is, designing and implementing methods to solve the problem. Once, first decomposition, next is pattern recognition, third is abstraction, and fourth is algorithm designing. So this is the process, or this is the characteristics, or this is the process or steps involved in computational thinking, in solving a problem. Okay. So next slide, please.
Excuse me, sir.
Yes.
Sir, keeping in mind your last example that you have given, that sum of series. So see the composition, like when you have broken down your problem, like 1 200 199, this 2 this way, so that is the decomposition. And can you say what is the pattern into that?
201 is the pattern. So you have found
Okay.
all the similarities.
Okay, and then abstraction where similar.
In this, actually, there is no abstraction part, because simply we have found out the pattern and we have applied the code. That code is nothing but 100 into 201. That is your algorithms.
Okay.
Okay. Okay. So, so this is regarding this computational thinking. What are the steps involved? Is one is decomposition, second one is pattern recognition, third is abstraction, and the fourth one is algorithm. Okay. Now decomposition. What is decomposition? As I have already told, the breaking problems into very simple parts. Breaking the problems into very simple problems. So parts. So only thing what is required is that logical reasoning. Logical reasoning is the only thing which is required for this decomposition. What is meant by logical reasoning? Say, for example, logical reason. One of the best logical reason example I could explain is, I could quote is, because as I'm a physicist, I could give examples with physics background only. So sorry, but still it could be very nice to hear. One of the logical reasoning is that, see, for example, there was a very big tussle between the scientists to prove whether light is a wave or light is a particle. Many scientists told that light is a wave. I am telling the scenario around 1900s to 1950s. So Huygens, Michelson, and many scientists were very keen to prove that light is a wave. And they told that, say, only a wave could be used, only a wave could have the property of diffraction, reflection, refraction, and those things and all, or not matter could be having. So as this light has the property of this refraction, reflection, diffraction, and those things, dispersion, even dispersion could be happening. And this kind of things are wave-like nature only. So nature, that is light, is a wave. So this was proposed by this Huygens and Michelson and those things, those scientists. And after that, Newton's corpuscular theory, and Newton and others told that light has what kind of nature? Only that is particle kind of nature. Why particle kind of nature? So if according to law of conservation of energy, energy can either be created or not be destroyed. But if there is energy coming from a source, if there is energy, means it has to come from a source, and that source must be from a matter only. So light has energy, and that energy is coming from the material or a matter inside that. So light could be considered as a matter only. So these are all the things proposed by the scientists. So light was a wave, light was a particle, like that. There was a very big tussle, and they have come to a conclusion that light has dual nature. What dual nature? What dual nature? It can have wave-like nature and also
Wave
particle
nature and
nature.
particle nature. Yes, sir. Thank you.
Yes. So this was that proposition. One good scientist was hearing all these things, and he came to he agreed with the conclusion. He didn't stop with that. He started thinking logically and differently. So he was, any guess? Yes. He was de Broglie. He was de Broglie. What he thought is that, so if light could have dual nature, like wave-like nature and particle nature, why can't matter can have wave-like properties? His PhD thesis was around 1.5 pages only, sir. You won't remember, you won't agree, or you won't believe. His PhD thesis is as of now, till now, this is the best known thesis in the world, and his PhD thesis is for 1.5 pages. And that thesis was accepted, and that is the best example for logical reason. So if this logic could happen, means why can't this logic? So what I'm coming to tell is that this kind of logical reasoning must be there in decomposition. So breaking a problems into simple parts is, by definition, it could be easy, but it needs lots and lots of logical reasoning in it. So if you can't solve a problem, then there is an
Excuse me,
easier
sir.
problem. You can solve it. Yes.
Excuse me, sir.
Yes.
Can you please mute everybody from your end? Somebody is speaking and we are not able to listen to you clearly.
Yes, sir. Host, sir. Murugan, sir. Could you do anything?
Yes, yes, it is already muted for all the participants. Go ahead.
Okay, sir. Thank you. So this complex problem could be disintegrated into many small problems. This could be some. So next slide, sir. Murugan sir, next slide, please. Yes. Thank you. If your problem is not decomposed, so why is decomposition important? So if a problem is not decomposed, it is much harder to solve. By seeing itself, you will be feeling that, oh, it is a very big problem. How can I interfere and how can I solve it like that? So dealing with many different stages all at once is much more difficult than breaking a problem down into a number of smaller problems and solving each one at a time, one at a time. So this breaking the problem down into smaller parts means that the smaller problem can be examined in more detail. Could be examined in more detail. If it could be examined in more detail, more results could also be obtained. Similarly, trying to understand how a complex system works is easier using decomposition. So, say for example, understanding how a bicycle works is more straightforward if the whole bike is separated into smaller parts and each part is examined to see how it works in more detail. For that, see, the best thing is that, see, for example, if you give, I don't know how many Punjabis are there in this participant list. Punjabis, if you give any kind of instrument to them, they will easily disintegrate it and they will refix it. They have that great what to say, that technicality with them. All the Punjabis. Okay, so the next slide, please. So let me quote some example, and so a very small example of brushing our teeth. This is a problem. Brushing our teeth is of course, everybody has this problem of brushing our teeth in our childhood days, no? So to decompose this problem of how to brush our teeth. So what are all the things we need to consider? What are all the things we need to consider? One is which toothbrush to use. First one. Next one, what is it? What toothpaste to use? Revati madam, please mute. Revati madam, please mute. Okay, so which toothbrush to use, how long to brush for, how hard to press on our teeth, and what toothpaste to use. So these are all the points to be considered. So the problem of brushing our teeth could be addressed with these four problems, these four questions. So this is called as disintegration or decomposition. So in mathematics, we'll be having very good things like differentiation, say like full differentiation, partial differentiation, and integration, and those things and all. Differentiation is nothing but this disintegration or decomposition. So I used to explain in the class for partial differentiation. I don't know how many max participants are here. For simple explanation for what to say, differentiation, and what is the main difference between full differentiation and partial differentiation. I just don't want to go for any technicality in it. So for the ease of understanding, what I will tell is that, say for example, I just wanted to share this with you. Full differentiation means you can quote Sita. In the Ramayana, Sita, Rama is the husband of Sita, you all know. So if Sita has to take any decision, and if Sita has to do anything, means it is enough that she gets permission from Rama. I'm not telling any male chauvinistic behavior, but for the sake of understanding, I'm telling. If Sita has to decide anything or to do anything, she has to rely upon, or she has to get consent from Rama. So in that case, This is called as full differentiation. So a variable or a very physical phenomena which is dependent on only one another physical phenomena. Say for example, x is varying with respect to time. So that is called as dx by dt. So this is full differentiation. So how can you explain partial differentiation? As Sita came, Draupadi also should come. So I am quoting another example from Mahabharata, where Draupadi, if Draupadi has to do something, means what she has to do? She has to get permission from. She has to get permission. Pancha Pandavas. So all Pandavas. So is it not? So all 5 members. So here, one physical quantity or one physical phenomena is dependent on 5 another variables or 5 another physical phenomena. So that is called as partial differentiation. Dou x by dou t, dou x by dou s, dou x by dou v, something like that. So this is how we can easily explain the things to the students. So for the sake of understanding, I told. So next one is example 2. Example 2 is solving a crime. So these examples are for decomposition only. These are for decomposition. So for solving a crime, if imagine that a crime has been committed. Okay, and you are a police inspector and you are asked to crack the crime scene. What all you will answer? What all you can do? If you are answering these 6 questions, if you are disintegrating the very big problem of solving the crime into these small problems, what crime was committed? You have to answer first this. After that, when the crime was committed, where the crime was committed, what evidence is there? Is there any more? Is there any witnesses for this? If there have been recently any other similar crimes, if you are able to answer this, then you can easily figure out what has happened or what is. So this is the main thing in any solving any kind of problem. So first thing is decomposition. Next one. Next slide. So next slide, please. Yes. Next one is pattern recognition. Next one is pattern recognition. I used to quote one movie. I think you might be all have been known about knowing this movie, Final Destination. Final Destination. It has some 7 series. It thinks 7 series of Final Destination movie has come. It is the best example for pattern recognition. In that, they will be telling death has its own pattern. Death has its own pattern. That is the one-liner of that movie. Okay. So what is meant by pattern recognition? Pattern recognition. The goal of pattern recognition is to find common similarities and differences among objects. The goal of pattern recognition is to find common similarities and differences among objects. This allows us to solve seemingly diverse problems by a single algorithm. Say, for example, I can quote one real-time example. One husband and wife has some misunderstanding and they are going for a divorce case and they are going for a court of law. The first thing what they will do is that they will be sending a counselor, and that counselor will try to convince these 2 people first, the husband and wife. See, we have lots of misunderstanding. Of course, I agree with that. There could be some similarities between you, and try to celebrate that similarity. Of course, there could be many kind of dissimilarities, but there will be some kind of pattern kind of thing, similarities kind of thing, and in any kind of problems also. So this, if you are able to pick up that similarities, that is called as pattern recognition. It is called as pattern recognition because nature loves symmetry. If there is symmetry, means there will be symmetry. If there is symmetry in the world, means there will be similarities also in the world. So next slide, please. So this is the next slide. So example of pattern recognition is, see, if you are ordering some kind of a shoe stand or a wardrobe stand through Amazon, you will be getting small kind of things only. You will be having some rods and things. And if you are able to assemble it, then you will get a wardrobe kind of thing. So this is an example for pattern recognition, putting together like in a furniture. Next slide, please. Next slide, please. So what is pattern recognition? When we decompose a complex problem, so first and foremost thing is disintegrating or decomposing a problem. So no, sir, previous slide. So when we decompose a complex problem, we often find patterns among the smaller problems we create. So these patterns or similarities are characteristics that some of the problems share. So pattern recognition involves finding the similarities or patterns among small decomposed problems that can help us solve more complex problems more efficiently. So once decomposed means, so if in that decomposed problems, you will be able to find the similarities or patterns. So this is called as pattern recognition. Next slide, please. Next slide, please, sir. So what are patterns? So imagine, we are given to draw a series of cats. You are asked to draw a series of cats. So what we can do is, first we have to see for any common characteristics of all the cats. What are the common characteristics of all the cats? All the cats will be having 2 eyes. All the cats will be having 2 ears, and they will be having tails and fur. Of course, these are all common things. They also like to eat fish and make mewing sounds. Okay, there you can find many similarities if for a group of cats. Because we know that all cats have eyes, tails, and fur, we can make a good attempt at drawing a cat simply by including these common characteristics. By including these common characteristics, we can somehow manage to draw a cat. So this is called as a pattern. This is called as pattern. So in computational thinking, these characteristics are known as patterns. So once we know how to describe one cat, we can describe others simply by following this pattern. Other cats could also be described with this pattern, but some with some cosmetic changes. What are the cosmetic changes? One may have green eyes, a long tail, and a black fur, but another cat may have yellow eyes, a short tail, and a striped fur. So this is called as pattern recognition. So next, why do we need to look for patterns? Why do we need to look? Sir, no, sir. Previous slide. Previous slide, please. So why do we need to look for patterns? Finding patterns is extremely important. It is very, very important. The patterns make our task very simpler. The problems are easier to solve when they share the patterns. Because we can use the same problem solving solution wherever the pattern is. The more patterns we can find, the easier and quicker our overall task of problem solving will be. So this is the need for patterns. Next slide, please. So if you want to draw a number of cats, finding a pattern to describe cats in general, that is, for an example, they all have eyes, tails, fur, and so these kind of things makes the task easier and quicker. So this type of finding a pattern is a very easy, easier task, which makes the programming easy and quicker. We know that all cats follow this pattern, so we don't have to stop each time we start to draw a new cat to work this out. So from these patterns, we know cats follow. We can quickly draw several cats. So this is what is the importance and the need for patterns. Okay. So next slide, please. So recognizing patterns. Find the patterns in the problems. We have to look for things that are same in each problem. So that is how we could recognize patterns. So patterns exist among different problems. And within individual problems also, patterns exist. So we need to look for both. We need to look for both. What kind of what both means what? Patterns within the problems, within the individual problems, and also with among different problems. Now we'll see patterns among different problems. Patterns among different problems. To find the patterns among problems, we look for things that are the same for each problem. Next slide, please. Next slide, please. So, for example, you are given a task of baking a cake. You are given a task of very simple task of. No, sir. Previous slide, please. So you are given a task of baking a cake. So we will just what if this is the problem is what we have to do. We have to first decompose into small problems. What are the possibilities to smaller problems? What kind of cake we want to bake? What kind of cake we want to bake? And next thing is what ingredients we need and how much of each ingredients are needed for baking a cake. How many people we want to bake the cake for? So how long we need to bake the cake for? And next, when we need to add each ingredient, what equipment is needed. So these are some problems I have identified for baking a cake. Okay, so once if you are finding out or decomposing some problems, some complex problems into smaller problems, then what you have to do is once we know how to bake one particular type of cake, we can see that baking another type of cake is not that much different because we will be having some kind of patterns. There exist patterns. For example, each cake we need a precise quantity of specific ingredients. So if you code these ingredients, specific ingredients as a pattern, then it will be easy for us. Ingredients will get added at a specific time and each cake will bake for a specific period of time. So these are the patterns. These are the patterns. So first we have decomposed, next we have patternized. So next slide, please. Next slide, please. Yes. So once we have the patterns identified, we have identified the patterns, we can now work on common solutions between the problems. So previous slide, sir, please. Yes, this thing. So here we are given a process, a problem of taking two different types of cakes. So the one is given in the left side and another one is given in the right side. So we are preheating one has some instructions, another have some another instructions for making the cake. But the pattern is similar here. Preheat oven to temperature. The temperature significance, the amount of temperature is here immaterial. The pattern is you will be preheating the oven to some temperature. What is the another pattern? Whisk quantity of ingredients. We are whisking the quantity of ingredients. And next, bake for some time. So this is a pattern. First preheat, next whisk, then bake. So this is a common pattern. If you are identifying this common pattern, then it will be easy for you to go for algorithms. Okay, so this is called as pattern identifying or pattern recognition. Next slide, please. So now we'll see patterns within a problem. Patterns within a problem. So patterns may also exist within smaller problems. We have decomposed too. So if you look at baking a cake, we can find patterns within the smaller problems too. For example, for each cake, we need a precise quantity of specific ingredients. Each ingredient needs, say for example, identifying a specific measurement. Once we know how to identify each ingredient and its amount, we can apply that pattern to all ingredients. So this is how identifying a pattern within a given problem. Again, all that changes is the specifics. Okay, next. Next slide. The next thing is abstraction. So abstraction is the process of filtering out unnecessary information. So what we have done, what we have done is we have decomposed and we have found some kind of similarity within the problems or in between the problems. This is what we have done. After that, we have found out the similarities and we have to detach some unnecessary information, and that is called as abstraction. Abstraction is the process of filtering out unnecessary information. So abstraction allows us to create a general idea of what the problem is and how to solve it. So it gives a general idea of what the problem is and how to solve it. So first process involved is decomposition or disintegration. Next one is pattern recognition, and now we are filtering out the unnecessary information. That is called as abstraction. That is called as abstraction. So abstraction, what does it has? What does it do? It filters. It filters out essentially ignoring the characteristics that we don't need in order to concentrate on those that we do. Say for example, in computational thinking, we look for patterns. Okay. And within the smaller problems and that make up the complex problem, we are identifying the patterns. So abstraction is the process of filtering out, ignoring the characteristics of patterns that we don't need in order to concentrate on those that we do. So it is also the filtering out of specific details. So general characteristics is there, and just those general characteristics are those are being identified as your patterns. Those specific terms or specific details or the cosmetic details which we are adding is called as that will be filtered out. So after filtering out that specific details, it becomes an abstract. From this, we create a representation of what we are trying to solve. Okay, so this is called as the next one. So abstraction is the process of filtering out, ignoring the characteristics of patterns that we don't need in order to concentrate on those that we do it. So this is what is called as abstraction. Next slide, please. Next slide, please. So, yes. What are the specific details of characteristics? No, sir. So, previous slide, please. Sir, previously, yes. In pattern recognition, we looked at the problems of having to draw a series of cats. So in the previous problem, you are trying to draw a series of cats. No, you will take the same example. So we noted that all cats have general characteristics which are common to all. Example, eyes, tail, fur, and ears, and those things. Okay. So here, a liking for fish and the ability to make mewing sounds. These are special characteristics. These are specific characteristics. No. So these details are known as specifics. In order to draw a basic cat, we do not need to know that it has a tail. We do need to know that it has a tail, fur, and eyes. We don't need to know what sound a cat makes or whether it likes fish or not. These characteristics are irrelevant. So we can filter out these irrelevant things, like whether it likes a fish or not, and whether it is what kind of sound it makes while it is something like that. So these things are not relevant. So these are specific characteristics. We can filter it out. So we do need to know that cat has a tail, fur, and eyes, but we don't need to know what size and color these are. These specifics can be filtered out. So after these specifics are filtered out, what you are getting is called as abstraction. What you are getting is called as abstraction. Next slide, please. Yes. So abstraction is the gathering of general characteristics and filtering out the specific characteristics. So this is what is called as abstraction. So when abstracting, we remove specific details and keep the general relevant patterns only. General relevant patterns. So this is called as abstraction. So so far what we have seen what is meant by decomposition, what is the process of decomposition, and next pattern recognition, and now we have seen up to abstraction. Next slide. So abstracting a general procedure for baking cookies. So it is enough that if you go with this kind of things, bring butter and eggs to room temperature. Okay, swift dry ingredients, cream, sugars and butter, add eggs and vanilla, mix in dry ingredients, mix in, add in chips, nuts, etc. and then bake. So this is a general procedure for baking cookies. Okay, so this is what we arrive at after performing decomposition, pattern recognition and abstracting. Okay, next slide please. After doing all these things, we have to go for creating a model. So a model is nothing but a general idea of a problem we are trying to solve. For example, again I am going to the cat problem. A model cat would be any cat, not a specific cat with a long tail and a short fur. A model represents all cats. From our model of cats, we can learn what any cat looks like using the patterns all cats share. So this is a model. Okay. Similarly, you will quote the other example when baking a cake. A model cake wouldn't be a specific cake. Here, a model cake wouldn't be a specific because we have not added any cosmetic changes to it, like a sponge cake or a fruit cake. Instead, the model would represent all cakes. From this model, we can learn how to bake any cake using the pattern that apply to all cakes. Okay, so once we have a model of our problem, we can then design an algorithm to solve it. So far what we have done, so we have taken a big problem and we have tried to decompose into a smaller problems and try to address the small problems. Okay, after that what we have did, within a problem or within two or more problems, we were trying to find out the similarities existing in between the problems, and that we picked up and called it as pattern recognition. After doing pattern recognition, we are abstracting. What is meant by abstracting? We are keeping the general characteristics and we are filtering out specific characteristics. After this abstraction, we are creating a model with these kind of. So after a model is created, then it is easy to work over it. So we can then design an algorithm to solve it. Okay. So what is an algorithm? What is an algorithm? So next slide, please. An algorithm is a plan, a set of step-by-step instructions to solve a problem. So this is called as an algorithm. In an algorithm, each instruction is identified and the order in which they should be carried out is planned. Algorithms are often used as a starting point for creating a computer program. And they could be a flow chart or simply it could be a pseudocode. These things and all, I think. But if you want to tell a computer to do something, what we have to do? We have to write a computer program that will tell the computer step by step. You have to do this first. After that, you have to do this. After that, you have to do this. Exactly what we want it to do and how we want it to do. So this step-by-step procedure is called as algorithm. This step-by-step program will need planning. And to do this, we use an algorithm. So computers are deaf and dumb. No, is it not? It will do what you are telling. It will do what instructions you are. So if it is not working properly, the instructions what you have given is wrong. That is only implied. Okay. So the computers are only as good as the algorithms they are given. If you give a computer a poor algorithm, you will get a poor result. Hence the phrase garbage in, garbage out. So if you give a computer a poor algorithm, you will get only a poor result. Next one, sir. Next one, please. So this is an example problem, that is algorithm, computer algorithm for multiplying a number by an integer, multiplication by using addition. Say for example, assume that a computer has the ability to do addition, and we want to multiply something like given 351 into 14. So here let A be a given number which we want to multiply by an integer b. This is called as, for what we have given is a pseudocode. This is a pseudocode for our algorithm because it does not use any language specific terms. You don't have to give any you are not running any program. You have not given any syntax for it. So this is called as this is called as a pseudocode. This is called pseudocode for our next slide, sir. Yes. So for designing algorithms, what are all the steps? First, you have to determine the right steps. First, you have to determine the right steps, and after that, determine the correct order of steps. We have to follow the steps completely. And next one is verify that the algorithm is working correctly. First, you have to verify, then we have to verify, and next is they determine if this algorithm is the best approach for solving a problem. So many it is not necessary that all the approach, all the you are approaching the problem in a right manner or not. You could have, one could have approached it in a different manner, and likewise the algorithm could have been different, and another person who is approaching the problem could have approached it differently, and his algorithm may have been different. So we have to know whether this algorithm is the best approach. There could be many approaches for solving a problem, and based on that approaches only, based on that logical reasoning only, you could have created a model, and based on that model only you could have created an algorithm. This algorithm is a brainchild or a child of what the model what you have created, is it not? So if the next thing is to determine if the algorithm is the best approach, whether your algorithm is the best approach for solving a problem. Okay, next slide please. So this is a model algorithm. This is nothing but simply say for example, you are getting an input, what you are getting your name, and you are getting an input like how old are you. So if you give an age, if you give your age, and if your age is greater than 70, you will be prompted as you are aged to perfection. If you are less than 70, the output will be you are a spring chicken. So this is a small algorithm to say, to note down, to tell whether based on your age you are a perfection, you are a aged perfection, or you are a spring chicken. So this is a small algorithm, and these symbols and usage of that symbols is given in the right side.
Excuse me?
Yes?
Sir, after the start, it should be input. What is your name?
Yes, input. Yes, input only. What is your name? Yes. No, sorry, it is an input. Yes. Yeah, what is your name is an input. Input only.
Okay.
So it has been given output. Yes. So next slide, please. So I will quote an example, and I'll be if time permits. So how long is the time, sir? How long time do I have, sir? Murugan, sir?
5 minutes, sir. 5 minutes.
So 5 minutes. Okay. I will just hurry up with what I have. See, suppose I have given one example problem and 3 algorithms for this. So you can by viewing itself you can see this. Suppose you are packing your backpack, but you have only 6 items you are interested in taking, but the total weight is 96 pounds. The maximum weight you are willing to carry is 50 pounds. So you assign each item an importance value between 0 and 25. The higher the number, the more valuable. So what items should you take? This is the problem. This is the problem, and you have given item, weight, and value. So how do you approach this problem? Use using this computational thinking and those things and all. So this is the model. Somehow you have got the model. Now you are just prompted to write an algorithm for this. You are just prompted to write an algorithm for this. So first algorithm, we simply what we can do, we can simply pick an item at random and put it in the backpack. We then weigh the backpack, and if it weighs less than 50 pounds, then we pick up another item. If it weighs more than 50 pounds, then we remove the last item and try another item at random. So this is based on randomness. This first algorithm is based on randomness. Okay, so this is what this thing. Put all the items in a selection pile. If there are any items in the selection pile, pick an item at random from the selection pile and put it in the backpack. There are no items left in the selection pile. You are done. Now weigh the backpack. If it weighs less than 50, go to step 1. If it weighs 50 pounds, you are done. If it weighs greater than 50 pounds, remove item from backpack and from selection pile. Return to step 1. So this is the algorithm. The strategy behind this algorithm is randomness. It can generate any possible solution if we perform it many times. Is it not? So this will be the answer. So this will be the answer what we'll be getting. Okay, random. This is random. This is one algorithm. So I will share this with the coordinators so that they can share the whole PPT with you. So you can easily, slowly you can see what is given in this problem. Next algorithm is, first we have chosen randomness. The second strategy is to pick the items in their order from most valuable to the least valuable. See, they have been given some weightage for valuability. No? So this, so next slide please. So this is what I have told. Algorithm 1, that is random 1, step 1, step 2, like this. Next slide please. So this is the result what we'll be getting for the first algorithm. If you follow the first algorithm, we'll be getting the result like this. You can slowly see this in the PPT when I'm sharing this. The next one is, next slide please. Yes, second algorithm. So the next strategy is to pick up the items in the order from most valuable to the least valuable. So this is the algorithm. I just don't want to read it out. You can read it out. Next please. So this is the next algorithm, that is third one. What kind of approach is that? Compute the ratio of value per unit size. Value per unit size and add items in order they fit. So these three algorithms, you can say, you can work out at these three algorithms and find out which algorithm is the best one. Which algorithm is the best one? So next slide. Next please. So for the want of time, I'm skipping these slides, but you can easily see by watching itself, you can easily see. Similarly, I have given another one problem. Consider an algorithm. So the previous slide, sir. So consider an algorithm for counting. Specifically, we will determine the number of people in a room. So you have to find out an algorithm for counting the number of people in a room. So the step is also given, and the output also given. You can watch out it. Next slide, please. So this is the output of that algorithm. Next slide, please. So I insist that if you read these algorithms, we have given 2 examples, and I have given 4 algorithms. 2 examples and 4 algorithms. You can watch out it, and you yourself decide the output. What will be the output of that algorithm, and which algorithm is the best. Sir, thank you. So for the want of time, I have skipped some of the slides. I think I have finished. Thank you, sir. Thank you for your listening. Thank you, participants, for a wonderful cooperation what you have done.
Thank you, sir. Thank you so much.
Thank you, sir, for your wonderful lecture.
Thank you, sir. Thank you so much. I have to thank Murugan sir for sharing the screen. Thank you so much, sir.
Welcome, sir. Thank you.
Sir, can we talk to Srinivasan sir for just 1 or 2 minutes?
Yeah, sure.
Sir, as nowadays, like lot of emphasis on computational thinking to learn programming and all. So I want to ask you, sir, when we start teaching programming at a very early stage, like nowadays coding too much we are talking about. So like how we can start, means what are the resources we need in order to like teach the programming to a student starting from class 6 onwards?
For if you go for this computational thinking, no needed, sir. Only thing what you are needed is a logical reasoning. So that's what I was telling. If you logically, the main thing in approaching a problem is a logical reasoning. The logic what you apply is the main thing. So if you properly use this computational thinking for solving any kind of problems, it is not restricted to a computer problem, sir. It could be used for all the problems, all complex problems. First you have to, so if you follow these steps, then itself it is easy, sir. For all it is for day-to-day problems also. This computational thinking concepts can be applied.
So, sir, means what are the way to learn these things in a step-by-step manner, computational thinking at a child age?
Yeah. There are plenty of resources available on the website, sir. I can quote some links to you.
Yes,
if you are interested, you can text me, and I can give you the web links. So there are plenty of web links for right from kindergarten up to the age of some 11th standard or even 12th standard. They have special for that, and I can only, sir. I can give you the links so that you can easily approach it in a step-by-step manner.
Okay, sir. Okay, sir. Thank you very much, sir.
Sure. Yeah, thank you, sir.
Hello,
Welcome.
Srinivasan sir. This is Asma. So thank you very much for
Yes.
this insightful session, sir. I really enjoyed your session, and by far this was the best one. You have taken very good examples. You have related the topic with each and every real-time example, sir. I really liked your session. Thank you so much
Thank you.
for joining us.
Thank you, madam. Thank you. I'm on.
I agree with.
Yeah, literally true, sir.
We have
It was a
Thank you,
fantastic
sir.
session. Really, we did not feel like something out of our minds because as a teacher, we don't know these all the technologies and all. Before sir was asking no how to go for decoding and all, literally how the algorithm helps we understood. Now and then I will be seeing my son working for the engineering exams, but you made us to interfere into that knowledge. Literally, we felt
Sure,
very
madam. So thank you so much. I'm honored.
Yes, sir. It was really very, very interactive, and your language was also very understandable. Thanks a lot. Thanks a lot, sir.
Yeah, thank you. Thank you so much.
Excuse me, sir. If Mr. Shivasan sir's mail ID can be shared with us right now on the board, so it will be good so that we may note it down.
Sure, I will text it, sir. Text it. I don't know how to text it, or otherwise I could. Uh,
It is
can you please note down
srini@ats@gmail.com.
I will text you, sir, or I will spell it now.
Yeah. See, participant, I'm just showing the Srinivasan sir mail ID. Just you can see my screen and I will be visible first.
Thank you so much, sir.
Sir, it was very nice session. A wonderful session. Srinivasan sir, thank you so much.
This is Srinivasan sir mail ID. Can you able to see?
Where is it?
SRINITS at gmail.com. NITS means NIT Sildan. Srini NITS at gmail.com.
Thank you, sir. Thank you.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Yeah. So thank you, participant. Thank you, Dr. Srinivasan. So for delivering a nice lecture and you are given some valuable time with our participant instead of your busy schedule. So I thank you on behalf of the entire organizing committee of this RISE 2020. Thank you very much.
Thank you, sir.
I am also a part of it. Thank you.
Thank you, Murugan sir.
Yesterday's
Thank you.
also they were very, very useful. Actually, we were scared to join artificial intelligence. As a teacher, what we are going to learn, so many doubts in the mind, but you made us to stick on to the screen. Literally, we did not move from the system, Everything we are listening. Thank you so much.
Thank you.
Yes, ma'am. Actually, we are also worried while preparing the schedule of this particular FDP because initially we planned for the engineering teacher, but later this workshop was approved for the CBSE school teacher. So we have a lot of discussion among the coordinator. So how to make plan for this schedule. And finally, we concluded that we have downloaded the CBSE syllabus according to the guidelines of ACPE. Then we have prepared this schedule like computational thinking, programming, and all the schedule which we have shared with you. So I think we are looking forward to some other, next day and the last day we have some interesting session also. I hope the participant will be benefited. So thank you all for your active participation. So with this, we break for lunch and next session will be started 2 p.m. Thank you all.
Thank you, sir.
Okay, thank you very much, sir. Thank you.
Thank you, sir.
Can we have Murugan sir, please?
Yes, sir. Yes, ma'am.
Yes, actually, I want to know that, sir, how can I get the certificate? What is the procedure to having the certificate during this seminar?
Certificates will be sent by ATAL directly to the participants. Okay, after
By
completing this, after finishing this FDP, you
via
will be
email,
able to, madam, after completing this FDP for 5 days completely, you need to send feedback. You need to fill the feedback form sent by ATAL. After that, you will be getting your certificates in your email.
Okay.
Yeah.
Okay, fine. Okay,
Yeah.
thank you.
It's okay.
Hello. Murugan sir, shall we start?
Yes, sir. Yes, sir. We can start. Sir.
Mr. Pramoda Singatalur,
Yes, sir.
could you
Namaste, sir.
please mute your mic? Namaste, namaste. Could you please unmute your mic?
Okay, sir. Okay.
Okay. Thank you. Thank you. So, so I welcome all the participants for the second session of 2020. This is this. Hello. So I think we can start the session. I have very privileged. I am very much privileged to introduce our resource person, Dr. Shankar. He is going to handle the session today. Dr. Shankar, Assistant Professor, the Department of EIE, NIT Silchar. He completed his undergraduate engineering degree in Instrumentation and Control Engineering discipline at Arulmigu Kalasalingam College of Engineering, Tamil Nadu in the year 1998 and MTech in Biomedical Engineering at IIT Madras in the year 2006. He was awarded PhD degree in the broad area of biomedical engineering from Anna University, Chennai in 2017. He has been teaching the instrumentation and allied engineering courses for two decades. Before joining NIT Silchar, he was serving in various positions from lecturer to associate professor in EIE Department of National Engineering College, Kovilpatti, Tamil Nadu. Dr. Shankar is more passionate in pain research and tries to explore the objectivity in pain. However, his research interests include the broad areas of biomedical instrumentation, human factors engineering, automation, environmental instrumentation, technology for societal issues, and entrepreneurship development. Dr. Shankar has published and presented research papers in various national and international journals and conferences. He has guided many PG engineering students and is guiding a PhD scholar. Above all, he is a man of virtues, principles, and a wonderful human being. I now invite Dr. K. Shankar to present his lecture. Over to you, sir.
Thank you, Dr. Srinivasan, sir, for your nice introduction on me. Especially the last few words you have said, it makes me embarrassed. Thank you very much. Thank you very much for your assessment. Nice introduction. Good afternoon, participants.
Afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Yeah, thank you.
Sir?
Yes. Yeah, thank you. Good afternoon, participants. I am very much happy to be here as a resource person in this ATAL sponsored faculty development program on artificial intelligence applications in science and engineering. So today's topic is about cyber safety and ethics. I know this FDP is organized for CBSE school teachers, so the organizers have set the schedule or the topics in such a way that we it should be useful for CBSE teachers when they are teaching lessons, computer science or artificial intelligence lessons in their schools to the students. So I have also prepared this presentation in a way to cover few topics in CBSE school curriculum, CBSE curriculum, CBSE board curriculum. But I admit to say that the contents which I am going to show in this presentation are not my research outputs, right? And I have not found anything new in cybersecurity and ethics because I am interested in cybersecurity and ethics, but I have not done any research on cybersecurity, and I have not prepared any, I have not generated any algorithms or computer programs to contribute in cybersecurity domain, right? So these are all the materials which you may find in internet and other sources also, but I have made these materials in organized way, right? I have organized these materials, and I'll be showing, I'll be presenting these materials for almost 1 hour, right? And there will be around some 20 slides, so I will not take much time. If you and I also request the participants to interact in between the lecture also, and at the end of the lecture also, if you need. And I know few of you are knowing this content much more than me, my knowledge. And if you have any more points want to add in this presentation, you are welcome. You can add. So let me share the presentation. I hope my slides are visible at participants here.
सिलेबस में कर हैं इतना अच्छा पेपर गया था मुझे नहीं पता था मैडम ने
I request the participants, please mute your mic. It will be convenient for us to continue. Okay. So this session is about cyber safety and ethics. So in this session, we are going to see what is cyber and what is the related words with the cyber, with cyber ethics, cyber space, or cyber crime and other things, and how we could be safe enough while we are playing in cyber platform, and what are the ethics we need to follow, or what are the norms we need to follow while we are doing some work in cyber platform or playing in cyber platform, right? So yeah. So let's divide these cyber safety and ethics in 3 parts. One is cyber, and another one is safety, and another one is ethics. So let's see about cyber. Cyber is a word, right? And it's a neologism. Neologism means derived from. It's derived from a word called cybernetic. But cybernetic was derived from the Greek word called Kubernetes. It refers to pilot or steers. Actually, cyber deals with the communication between human and machine. Initially, in the earlier days, the scientists, those who were working on cybernetics or cyber platform, they used this cyber platform for communicating with the machines. And the history comes from 1834, from 18th century. From 1834, the scientist Andre Marie Ampere, he coined the word cybernetics. This is Ampere. He coined the word cybernetics, and he coined the word cybernetics to denote the sciences of code. And later in 1948, Norbert Wiener used the cybernetics word in one of his books titled Cybernetics or Control and Communication in the Animal and the Machine. This is very important keyword, that control and communication with the animal and the machine. Nowadays, we are using cyber platform for this same purpose. And later in 1969, after Robert Wiener, two one artist and an architect. Artist is Susanne Wissing and Hoff. Right? She is Susanne Wissing and Hoff is an architect. They both use the word cyberspace, right, to articulate the vision on future physical sensory spaces via their artistic work entitled Atelier Cyberspace. You can find many materials in this title, Atelier Cyberspace, and they both use in this duo. Wissing is an artist and Hobb is an architect, right? So they used the word cyberspace in 1969, and after that, a novel writer named William Gibson in early 90s, he wrote many books, and he used the cyberspace word in his books, right? Two books he has written in science fiction, Burning Chrome and Neuromancer. In these two books, he has used the word cyberspace, and he introduced computer hackers and the concept of super intelligence in his books, right? Where the hackers came into the picture to the world. And he described cyberspace as a graphic representation of data abstracted from the banks of a computer in the human system. And in late 90s, that happened in early 1980s, and in late 1980s, cyberspace was introduced in computer graphics and virtual reality and computer graphic animated pictures, many things. And nowadays we are watching many movies and many computer animated videos, and we are playing with and we are working with those things. The origin was in late 1980s. And in 1990s, the cyberspace was associated with the networks, right? And it has become a de facto synonym for the internet and world wide web, right? Of course, that is true. Nowadays, cyber word, if we spell out the word cyber, then it will directly have a link with the internet and world wide web and other social networks which are available in the world wide web. Right? And it is used as an prefix and an adjective in many new, and it forms many new terms like cyberpunk, cybercrime, cyber classroom, and cyber law, and the cyber ethics, cyber safety, and many more. Right? And these words denote something digital or virtual related to computers and networks. Okay, so what we can understand from the word cyber is that it's totally related with the computer and the internet, or the world wide web. Okay, so this word is totally completely related with the computer, and we are more relying on computers, and we are doing many work on computers, so we should be very much safe, and we should follow certain ethics while we are using the computer and we are playing with cyber world. Okay, and the right side we are seeing the scientists, those who had relation with the cyberspace, cyber word or cybernetics or other related words with cyber. So what is cyber? What the dictionary says about cyber? So the dictionary says it's relating to or characteristic of the culture of computers, information technology, and virtual reality. Right. So I have highlighted two words here: computers and information. Right. So these two are very important terminologies while we are talking about the cyber. We need to consider. Right. So what is computer? Computer is nothing but a device, or we all know. It has both two important components: software component and hardware components. Right? Why we are using these software and hardware components in computer? Just to communicate with it. Right? So we need to communicate with a computer, and computer needs to communicate with a human. Right? How we are communicating? By using the data or the information. Right? So what actually software does in computer? It handles the data and information What is data and information? Data and information are nothing but we should consider this as a well, like data is a well, and the information is right. So nowadays in cyber world, the wealthiness of a person is decided by using the information which amount he or she is at. Right. So this is very important. Data is information. We are dealing with the data, and the computer is communicating with us, and we are communicating with the computer by means of the data and information. Right. So cyber totally related with the computers and information, and without computers and information nowadays we cannot imagine the human life. Right. So because we are getting many things from the internet, and we are getting many information from the internet, and we are of course we can say we communicate or we talk with each other by using this platform, computer platform, right, inside the platform. So we should be very much careful in handling this platform. Next comes the cyber crime. Cyber crime is nothing but it's a criminal activity, right? And what type of criminal activity is this? It targets or uses a computer or a computer network or network devices. Okay, and this is very important one. Criminal activity, cyber crime is a criminal activity. Whenever we use the crime, and whatever may be the, not only the cyber work or not only the cyber working on a cyber platform, wherever we are working and whatever we are working, and whenever we are working, we are given with opportunities to do some mistakes, right? The loyalty or the integrity of a person is decided based on how possibly or how closely he is taking those opportunities to commit a mistake, right? So cyber is a very open platform, and here there are many more opportunities to commit mistakes, and these mistakes are voluntarily done by certain group of people. Those group of people are called cyber criminals or hackers. Right? Why they are doing this type of criminal activity inside the platform? The answer is very obvious: to make money or to defame the persons, right? Or defame the organizations, or defame the country, or defame any such groups, right? Or to threaten someone, right? But the ultimate aim, the majority of hackers and cyber criminals are doing this criminal activity just to make money. Okay. And there are types of cyber crimes. There are types of cyber crime, and these are the types of cyber crime. One is email and internet fraud is one type of cyber crime, and identity fraud means stealing the personal information and used for their own purposes. Right? Why do we need others' identity? We can threaten him, and we can make money out of it. Excuse me. We can make money out of those others' identity. This is one type of cybercrime, and theft of financial or card payment data. Nowadays, we are using debit cards and credit cards of different banks, and we are using it for some e-commerce applications and other applications. So it could be stolen out, right? And these financial information and the credit card details could be stolen out by others, and the corporate data could be stolen, and other word called cyber extortion. Like it's nothing but demanding the money to prevent a threatened attack, right? So this is one type of cyber crime called cyber extortion, and another kind of cyber crime is cyber espionage, right? Where hackers access government or company data. Right. So it's cybercrime not only involves the stealing of individual data or stealing of individuals' information. Right. It also involves the stealing of government or companies' data or other organizations' data. Right. So the ultimate aim of doing criminal activity, cyber criminal activity is nothing but to make money. Right. So most of this cybercrime activities fall under 2 points. One is the criminal activity that targets or the criminal activity that uses computers to commit other crimes. Right. So we can target any organization, we can target any individual, we can target the hackers can target any companies, right? And by targeting those companies or those computers, we can commit other crimes. We can hack the computers, and by using those computers, we can commit other crimes, cyber crimes. Okay. So is cyber platform really unsafe? Yes, it's really unsafe, right? But we can use this cyber platform in a safest way also, right? For that, we need to follow some ethics, and we need to follow, and we need to make others aware about cyber platform to use the platform in a very good way, right? So what is nowadays world is a global village, right? Where world economies, cultures, and populations are interconnected. Right? It's a very small thing. Cyber platform has made the world as a global village, right? Where everything we can do. So coming to the Indian part, India with over 400 million internet users, its data of 2018 is the second largest international population in the world, which uses the internet most widely, right? Most predominantly. As per the 2018 statistics, in India there were 400 million internet users. As of now, means by now it should have been improved, right? Maybe some 500 million or 600 million of internet users will be there in India by this time, right? And we have World Wide Web. It offers the greater connectivity, and why we are using this World Wide Web for large scale progresses, right? And it's very important, and it's very much useful to use this World Wide Web because it connects everyone, right? It connects different corners of the world, right? And of course, it gives some very big advantages, very huge advantages. At the same time, it leaves the digital societies open to new vulnerabilities. Okay? The vulnerabilities means from anything, right? So hacking the computers or defaming the persons or looting the money or housing the underprivileged and anything. Right. So there are two sides for World Wide Web. One is the large scale progress in positive way, and another side it leaves the digital society open to new vulnerabilities, many more new vulnerabilities. Right? And cyber crimes have no borders. Right? It evolved at a pace at par with the emerging technologies. Right? We know how the technologies are emerging nowadays. Right. So on par with these emerging technologies, the cyber crimes have also improved, or cyber crimes have also evolved, right, on par with the emerging technologies, and it has no borders. Right. It expands it expands like anything. Right. So in 2017, there is a report where in Indian consumers part, they lost over $18 billion in 2018 due to the cyber attack, right? And in 2018, there were 27,000 cases were reported, right, in our country. And there are many petty online frauds to lottery scams and sexual harassment happened in our country, and it happens in the world, happens in our own country also. Right? So most targeted crimes in cyber platform is the banking and finance. So see, in 2017, there were $18 billion were lost, right, by Indian consumers. Right? So this is most important targeted area in cybercrime, which is banking and finance. Right? And cyber crimes also impact the public safety also, especially the minors and vulnerable sections of the society. That we can say directly, we can say the minors and vulnerable sections of the children and the youth, right? So this impacts the cyber crimes directly impacts the public safety. Right? in 2018 in India, over 2,000 cases in cybercrimes related to sexual harassment were reported. Over 7,700 cases were reported on cyber bullying against women and minors. Right. So these are not good numbers to consider, right? These are very bad numbers. 18 billion US dollars were lost and 27,000 cases were reported altogether in cybercrime umbrella, and 2,000 cases were reported in 2018 on sexual harassment, and 700 cases were reported on cyber bullying against women and minors. Right? See, this photographs shown is showing the data, like the scale of consumer cybercrime. About 4 out of 10 people have stated that they understand the risk of cybercrime and how to protect themselves. Right? This is awareness. This awareness has been created among the people, and these awareness must be taken in the right way, and they should follow the ethics. Right? And 7 out of 10 adults have been victims of cybercrime. Right? It's a very bad number. 7 out of 10 is 70%, right? And 1,15,000 plus victims a day in cybercrime, right? And $8 billion US dollar is looted, and 80 victims in neck in cybercrime. It's definitely not a good number. See, from 2011 to 2015, the number of crime cases, cybercrime cases, is keep on increasing. Right? Maybe in 2019 or 20, if we take, I didn't get those data. If we get those data, then it will be reaching 5 lakh or 10 lakh cybercrime cases. Right? So we should be very much aware about cybercrime and cyber safety. And this is another one data on a minute on internet, right? So we are working on internet, and we are very much involved in social networks and media, right? See, one statistical report says in 1 minute, 1 million logins are there in Facebook. It's, of course, it's worldwide data. It's 1 million Facebook logins are there, and 4.5 million YouTube videos are watched, and 1.4 million social. These two are social networks, right? Twitter network, and 46,000 about 46,000 new posts on Instagrams, and Netflix films are watched for 694,444 hours watched, right? And about 188 million of emails sent, and WhatsApp and Messenger, 41.6 million messages are sent to WhatsApp and Messenger, Facebook Messenger, and many more. And see, 1 million views are there, and 87,000, about 88,000 people are on Twitter in a minute, right? So it's a very big data. We cannot avoid, we cannot live without this social media network or social network or worldwide. Right? So if this is a scene, this is a scenario, how we need to be there, and how we need to be safe while we are on internet, or while we are using the social networks, right? That we are to decide. And is cyber platform really unsafe? Yes, because it's unpredictable. Cyber crimes are unpredictable. We don't know when the criminal activity will be initiated, and on whom it will be imposed. We do not know, right? Because this is unpredictable, right? And also it is ill-equipped. We cannot do it. Right? It's really impossible to tackle this type of criminal activity, and it's not possible to come out of this criminal activities done on as by somebody else in a quick manner. So it will take some time. We need to do. So the great philosopher Socrates said the most important thing is not life, but the good life. Right? The good life is most important thing. So nowadays we are looking for a life, and we can say we should be looking for a good life and safe. It's very important. Socrates said, and so to lead a good and safe life, we need to be more ethical. We need to be we need to concentrate on the safety measures when we are using the cyber platform. Okay. It's very important thing. And there are manifestations of online threats, which these slides, these pictures I have taken from CBSE academics for the president. And there are many abuse, many threats, and exploitation happen in India, especially to the younger generation. Like cyberbullying is happening, online sexual abuse is happening, and online sexual exploitation, and cyber radicalizations, online attacks, and also online enticement. What is cyberbullying? It's an emotional harassment. Right? It defame or it exposes to other level. It exposes the community group of people, kind of people to other level media, right? And it made the social exclusion. Cyberbullying makes the social exclusion, and online sexual abusement is also happening. This means the sexual harassment, right? And online sexual exploitation is also a type of sexual harassment. We can say this is a production and consumption of child sexual abuse materials comes under the online sexual exploitation, right? These all things are criminal activities inside the platform. So we should not make these things happen inside the platform, right? And online attacks are happening. These attacks are on devices, spreading some viruses or malwares on some other computers or some other systems, right? And exposure to inappropriate content, right? And identity theft, phishing, hacking, and privacy breaching. These all things come under the online attacks and threats, right? So there are a few things. One is cyberbullying and sexual abusement, and sexual exploitation, radicalization, and online attacks and frauds by using malwares and viruses and online enticements. Right? So these things should be avoided, and we should be aware these things are happening in the cyber platform, because we are using these cyber platforms for many of the purposes of us, and we cannot live without these cyber platforms, right? So we should be aware about this. And few cyber attacks in other few slides we'll be seeing. We'll be watching few cyber attacks happened in India in recent past. Right, there was a cyber attack in Bangalore. It's a SIM swap fraud. Right. So what those hackers then they have swapped the SIM of the users, and by using their original SIM, the user's original SIM, they have looted money from their bank accounts. The user's bank account. They have looted almost 4 crore Indian rupees in August 2018. Right? It was a very big scam. It was considered a very big scam in 2018. So the hackers used the SIM cards of mobile phone of the users, and they stamped with other numbers, and they used the original numbers which are associated with the bank accounts. Right? So we are giving some. Nowadays we are connected. Right? We are connected with our phone, our bank accounts, our Aadhaar card, our PAN card. All the data are interconnected, right? So if we hack one data of ours, of somebody else, then we can trace other things also, right? So these hackers have used this SIM card to hack the bankers' accounts, right? Means the individuals' accounts, and they have looted some 4 crore Indian rupees. It was highlighted in the newspaper also. And the next one is on Cosmos Bank, right? And where some 94 crore Indian rupees was looted. It happened in Pune branch in 2018, right? So money was withdrawn from ATMs in 28 countries, including Canada, Hong Kong, and India, but from the account holders of Cosmos Bank of India. Right. So in this cyber attack, mastermind was not found yet, and those arrested may be money units. Right. So it's a very big cyber attack happening in August 2018 back in September. And Big B, Amitabh Bachchan's Twitter account was hacked, right? And it was used for other purposes, and it was also hacked. And this is called one type of defaming the popular figures, right? And we all know our other UADA other portal was hacked, right? If we in 10 minutes, we could have access a billion of other templates for finding this cost, right? It was very big cyber attack happened in our country, and there were other cyber attacks also happened in our country. The Kodamangala nuclear power plant website was hacked, right? It was actually a malware attack. The virus was spread in the website in October 2019, and our Indian journalists were attacked by Israeli spyware, right? And personal data exposed from the Western database. These are very few cyber attacks happening in India, and there are many more cyber attacks happening in our nowadays. Every moment it's happening, and we should be very much aware of it. So what to do? We have seen what is cyber, and cyber is a word which was coined from cybernetics. It was derived from Greek word. Many from 1800s, this word is being used till now. Now we are living in the cyber platform, and we are doing work on cyber. And without cyber platform, we cannot live. This is the situation now we are living with, and we have seen many cyber attacks happening in our country, in our society, in the global system. Right? And but what to do? We need to live with this environment. So how we should be and what we should do while we are living in this environment, right? There are few basic elements, 9 basic elements of digital citizenship. It's a new word, digital citizenship. We are all citizens of a country. Now our country is a digital country, and so being a citizen of a digital country, we are digital citizens. Right? So we are acquiring digital citizenship. We are owning the digital citizenship of our country. Right? So there are 9 basic elements in digital citizenship. One is digital access, and second one is digital literacy, and third one is digital communication. Fourth one is digital commerce, digital etiquette, digital health and readiness, digital rights, freedoms and responsibilities, digital security, and digital law. Right. So digital access, each and every citizen, and every citizen in the country should be allowed to access or should be given the digital access. Right. It's government initiative. Right. Government is taking nowadays more initiatives in giving access to all the country's citizens. Right. And digital literacy, it is individual awareness. Actually, this individual awareness should be there on other 3 parts also, including the digital literacy and digital health and wellness, and digital rights, freedoms and responsibilities, and digital security. Right? Digital literacy. What is digital literacy? It is understanding the technology, right, and its uses, and its use is a basic condition for optimizing its benefits. Right? So we should understand what the technology nowadays is, and how we are using it, and how we can use this technology in a proper way to improve our lifestyle. Right? This is very important, and it should come from the individuals. Right? We should be aware about the technological improvement and the technological usage and technological purposes. Okay, and at the same time, we should maintain the digital health and wellness. Right? It's like balancing of your online and offline lives. Right? Nowadays, we are spending more time online than offline. Right? So, but we should balance these 2 lives, online and offline lives. We should balance, and it's the individual responsibility to balance these things. And we should know what we need to do and what are the rights we have on digital platform, right, or the cyber platform. and what are the freedoms we have, and what are our responsibilities while we are making some new course or some handling this cybercrime. It's individuals' responsibility, and we should be aware about the digital security also, right? And if suppose we are attacked with some cyber criminal activity, what should we do, right? Whom do we call? And how we need to approach the authorities to safeguard ourselves from the cyber criminal activities, right? So these are the individual responsibilities. We should know, we should have the digital literacy, and we should balance it online or offline life, and we should know what are the rights we have in the digital platform, what are the freedoms we have, what are our responsibilities, and we should know the digital security also available in our digital security forums available in our country, right? In other states, we will see this digital security also, right? And so government has two parts here. One is digital access and digital law. Law is made by the government and it should be enforced, and government is taking many initiatives in making the citizens to access the digital platform. And on the other hand, government is taking also the initiatives to make new laws and impose on cybercrime, right? And there are many things, many acts amended, or many acts included in this. Okay. And digital communication is kind of electronic exchange of information with other people through emails, cell phones, and instant messaging constantly and without delay. Right. This is digital communication comes under digital citizenship. Right. Here, the communication means it also includes the sharing the personal information, which includes the photos and videos also. Nowadays, we are sharing many photos and many videos of any kind, right? Maybe of good courses or bad courses, or we are making others in a wrong courses, and we are posting it in social media, right? These all things come under the digital communication, right? We are exchanging many information, personal information also, right? The personal information also includes the photos and videos of self or others, right? It's very important, right? So these are all very important things. Government has is taking initiative to give access to all the citizens, and is making laws and imposing on cyber platform. And individuals should have awareness about digital literacy and digital effectiveness, their rights on cyber platform. And, they should know the digital security forums available in the country, and they should be more responsible in communicating the information, exchanging the information in social media, right? And they should be very much aware while they are doing transaction on e-commerce websites, right, or the banking sectors, because banking and e-commerce frauds are most predominant frauds in cyber platforms, right? So what should we have? What should we have to be safe in cyber platform? We should be more ethical, right? So there are some ethics we need to follow, we should follow, and these digital ethics are called digital etiquette, right? So digital etiquette describes the norms for appropriate and responsible behaviors while using technological devices. Right? It's very much important. When we are using our mobile phone, we should be more responsible. When we are using the personal computer at our home or in our offices or wherever it is, in our school, in our college, wherever it is, we should be more responsible in using those platforms, right? Because our information are built for others, right? Our data are built for others, right? They can make money out of our data. They can make money out of our information. Right? So we should be very much cautious, and we should follow each and every citizen in this digital world should be more ethical, right? So this is very important thing. While we should educate our children, we should educate our students to use the effective use of digital media, right? Effective use of the digital gadgets, right? It's very important. Yeah, we should teach the ethics to the students and our children. So there are digital laws available in our country, right? So these digital law are the legal rights and restrictions governing which are governing the technological usages, right? So there are digital laws which are governing the technological usages, right? So law means what? It's a norm, right? You should be there. If it is not there, then he or she will be punished, right? He should behave in such a way in a digital platform. He should behave. He should use these technological advancements in such a way. Right? If something happens wrongly, then they will be put under the digital law and they will be punished. Right? So there are a few actions that are unethical or illegal inside the platform. Those unethical and illegal actions are software assisted piracy. Piracy is very much important word. It's a significant word inside the platform, right? So we should not pirate anything. We should not pirate the software. And we should not pirate the systems. We should not hack the system. This is unethical action inside, right? So downloading the music and films without authorization or payment is also illegal, and stealing other people's work, right? It's a plagiarism. Taking word from others' work, taking the concept of others' words, or taking the core of others' words for our purposes is a plagiarism. It's illegal, right? And it will come under the copyright infringement also. We should not copy or we should not use others' data without their consent, right? Without their permission. And illegal file sharing is also very much important point we need to discuss here. Illegal file sharing means file of anything, right? Your photographical file or your video file or any kind of file or your information, your data, right? Or your results of your research, anything. Sharing of others' file without their consent is illegal, right? And it's an unethical action. Hacking into other systems or networks is also illegal, right? So we have seen Amitabh Bachchan's Twitter account was hacked, right? It's a bad thing. It's an illegal thing, and it's against the law. Creating destructive viruses or bombs that causes damage to other people, not less, right? And it's also very very unaccepted, illegal things and unethical things, right? So we should not do these things. We should not distract other systems or other use other computers by using the viruses or other malwares, right? And sending spam messages is also very bad thing, and it also considered unethical or illegal action of cyber. And there are a few golden rules in digital law, right? So we should think before we act, right? It's very important. It means because whenever we are getting into the cyber platform, whenever we are getting into social platform, social networks, we should be very much aware about the rules or the norms or ethics of the particular social platform, social networks. Right? So why we need to think before we act? Because we may violate the law of the land, right? It's an unethical thing, right? So we should not violate any law of cyber platform, right? So we should think before we handle the business, before we handle the gadgets, before we handle the internet. Right? And ignorance of the law is also illegal, right? And ignorance of law cannot be considered as a valid defense to the belief, right? It's not a valid defense, right? So ignorance cannot be considered in this platform. And we should keep one thing in mind is that ethical is legal. Whatever we feel, this is ethic and this is whatever the legal points, whatever the law has been made by the government is an ethical point, right? So we should think before we act on digital platform or the cyber platform, because we will violate the law and the ignorance of the law, right, which are made by the government cannot be considered as a valid defense. Right? And whatever the legal or ethical, whatever the ethical or the legal. Right? So these are golden rules of digital law. We should keep these golden rules in our mind always when we are on the cyber. Right? And there are few illegal online activities. Right? The revenge porn is one type of illegal activity, right? Revenge porn is taking revenge on others by showing them in an inappropriate way, right? In a social media or the social network, right? It's a revenge porn. It's an illegal activity, illegal online activity, and violation of some other's privacy is also illegal activity, and impersonation, right? Is also an illegal activity. Unauthorized access, online piracy, plagiarism, which we have seen during the misrepresentation of some others' portraits or some others' and defaming the others, right? And all illegal online activities, pirating the things, copying others' information, and plagiarize, misrepresentation, defamation, everything comes under the illegal. So, what we have in our country to govern this type of offences? What are the laws we have? Right? There are few laws which are available in our country, right, which protects the children against the sexual offences. We have the Information Technology Act 2000. We have the Protection of Children Against Sexual Offences Indian Penal Code, or the Information Technology Act 2000, and we have POCSO Code, right? POCSO law also we have. POCSO means the Protection of Children from Sexual Offences. 2005 Indian Penal Code. It has 9 chapters and 4 to 6 sections. Right? So we may not be able to read all the sections of these chapters or all these acts, right? But we should know what are the laws available in our country to safeguard ourselves in the cyber platform, right? So, and the Copyright Act also there is of 1957, and Indian Contracts Act is also there. Right? So these are a significant act which are related with the cyber crimes, right? So we have Information Technology Act of 2000, and we have POCSO law, which protects the children from sexual offences, and we have the Copyright Act, and we have the Indian Contracts. Okay. So how we can use these acts? There are many forums available in our country. There we can approach if we are affected by the cyber platform, right? If we are affected in the cyber, if we approach those agencies, those coordinators, then they will make us to use these acts to punish acts, right? To punish the criminal, the cyber criminals. Okay. So these are the very important points we need to know. There are 3 significant acts: Information Technology Act, the POCSO Act, Copyright Act, and Indian Contracts. There are few cyber agencies available in Government of India, right, which are coming under the different ministries, especially 2 ministries. There are Ministry of Electronics and Information Technology, which has the Indian Computer Emergency Response Team. Indian Computer Emergency Response Team, all CEP-A, Computer Emergency Response Team India, right? And we have National Cyber Coordinate Center, which comes under Ministry of Home Affairs, right? And there is Cyber and Information Security Division, which comes under Ministry of Home Affairs, and we have National Cyber Crime Reporting Portal. Which comes under Ministry of Home Affairs, and we have Digital Police also comes under Ministry of Home Affairs, and we have Cyber Safe Portal, right? And these are significant cyber agencies which are governed by the Government of India, right? And let's see. I'm trying to open this website. Let me try. If it's open, then you will see some information on this website. Otherwise, you can note it down these websites, and of course, I will be sharing this materials with you. You can go through this. And Government of India has separate Twitter account for cyber activities called the cyber ghost, right? And it has some 239,000 followers, right? Means more than 2 lakhs followers it has, and there we can complain or report or we can get information regarding the cyber crime, right? We have CyCon, Cyber Coordination Center, right? Yeah, sure. So this is the website. I think you can see. Otherwise, you can see on your own, right? So there are agencies which are established by government of India to carry over the cyber activities, right? To monitor cyber activities in our country, to handle the cyber crime in our country, right? So the agencies are Indian Computer Emergency Response Team, the National Cyber Coordination Center, CyCon, right? CEPIN, CyCon, and CNA is division of Ministry of Home Affairs, and National Cyber Crime Reporting Portal, and we have digital police, smart police, and we have cyber safe, and Government of India has also initiated the Twitter account, also started a Twitter account for cybercrime activities called the cyber case, right? So we can get more information on it. We can complain if we are attacked by the cyber crimes, right? I think this is the end of the slide. Thank you very much. If you want to interact, then you can interact. Otherwise, you can close the session. Thank you. Srinivasan sir.
Sir?
Sir?
Yes.
The screen is not visible and not audible.
Yes, sir. It's over. So, if there are any discussions, then we can discuss.
The lecture is now open for discussion or any questions. If
Hello, good afternoon, sir.
Good afternoon.
Is it possible to have some kind of orientation program for students also regarding cyber safety?
Sorry, ma'am, you are not audible. Your voice is echoing.
Fine, let me find out the arrangement.
Anyway, my dear participants, I will be sharing these slides with you. You can go through it. I'll be sharing the slides with my contact details also. And discuss.
Madam, you are not audible.
Sir, I am not audible.
No, that madam, she asked the
Yeah.
questions, no? She was not
Yes,
audible.
yes.
So, does anybody have any questions?
Sir, can you please send this PPT because I have late joining due to
Sure.
Yes,
So,
we will be sharing these slides.
Okay, sir. Thank you very much, sir.
Good afternoon, sir.
So,
good afternoon.
Sir, I have a doubt.
Excuse me, sir.
Yes, ma'am.
Sir, can you explain the difference between phishing and email spoofing?
Phishing and?
Email spoofing.
Email?
Excuse me, sir.
Sorry,
Email spoofing. Phishing and email spoofing.
Yes, ma'am. Yes, there is a question about phishing of there may be. I'm not actually expert in phishing this type of technologies, no, but I am trying to explain the thing. Phishing, like kind of how to explain that? Yes, giving some information like attacking the other system, and getting information from other systems, other personal information is phishing, right? There are many ways, there are many attempts they are making, the hackers are making, and actually I am not fully aware about the phishing. I think in this way we can defend the phishing. If I am right, you can also some more points now. What is phishing? If you know, I invite the participants, other participants also to take part in this discussion. What is phishing and email spoofing?
Sir, may I?
Yes, please.
Like phishing is basically a criminal fraudulent where hackers try to pose like a real users to send something in the front of us. For example, suppose I'm acting like an RBI employee. I'm sending you some information like a RBI, but though it's not from RBI. And once you receive that mail, you start interacting behalf of that mail, assuming that it is from the bank. And you've already provided all the information fist. This is what the phishing is. So it's a criminal fraudulent on the net where the hackers try to present something like a real one, but it's not real at all. Fine.
Okay, like,
and email spoofing is, second
like
part.
we have shown that as SIM swap fraudulent activity. This will come under the phishing, right?
Of course.
Yes.
So
yes,
I'm acting like a real user, real sender of any documents, legal documents, where basically I'm trying to make you fool. That is what the phishing is. And in the case of like email spoofing, hackers try to spoof your email ID one or other way, and they start again misusing that email ID. That is what email spoofing is. I hope this is what ma'am is asking for.
Ma'am?
Yes, sir. Yes, sir. It's clear, sir. Now it is clear.
It's clear. Okay.
Yes, sir. Thank you. Thank you so much.
Thank you,
Thank you.
sir. Thank you, Pankaj sir.
Thank you, sir.
So if there are no more questions, so you are always invited to ask questions through email to the resource person, and he will answer to you. For the want of time, I think we can close the session as of now with a very big thanks to the resource person, Dr. K. Shankar. So now we understood that all which is good is equally bad, sir. The convenience of digital technology gives an array of positive, good things as well as equally bad things also. So it is up to us to use it effectively, collectively, and securely, safely. So with that note, I thank Dr. K. Shankar for his wonderful lecture, and I thank the participants also. Thank you.
Thank you, sir. Thank you so much. Thank you, participants, for your listening.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you very much to all of you.
Very nice.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you, ma'am.
Thank you, sir.
Thank you, sir.
Thank you very much, sir. Thank you.
Thank you.
Thank you, sir. Thank you very much.
Thank you.
Thank you very much, sir.
Thank you, sir. Thank you, sir.
Thank you very much, sir.
Thank you, ma'am.
Mr. Sankar.
Yes, sir.
Thank you for the session.
Every day we have our session, second session up to 3:30. Today we are winding up at 3 o'clock today.
Yes, sir.
Tomorrow timing will be 9:30.
Yes, sir. 9:30.
Can we leave now, sir?
Yes, ma'am. Yes, ma'am. You can leave. Session over.
Okay, thank you, sir.
Thank you.
Hello, Shankar sir.
Ma'am, please.
Sir, today I think that you were supposed to give the PPT of last 2 days.
Okay, ma'am.
Sir, it will be very kindful of you if you just share that PPT with us so that we can just go through.
Yes, ma'am. Yes, ma'am. We will send it, ma'am. Actually, the thing is that, ma'am, and other resource persons are yet to send their slides. So we are waiting for it. So what we are thinking, we can send it all together. So if you want immediately, then we can send the materials whatever we have now, right? And later we will send the others. Okay, we will send it now.
Actually, sir, it would be very helpful if you, whatever material you are having, at least you share that much only so that we can just go through that. All of
Yes,
sudden it is, we will not get so much time to go through, na? That is why.
Okay, okay. We will send it.
Okay, thank you, sir.
Thank you.